Hello, everyone. Alrighty, a little bit later than we expected. Sorry, I had some technical issues. Turns out one of my drives is just trying to give up. Alrighty, so let's continue with Zig. I'm actually really excited what we're gonna learn today. So let's kind of recap what we did last time because it was last week, and to be honest, I barely remember what we were doing. So, alrighty. So we were using the Zig book, right? We found it and get started. Hey, Taras. When hair? I don't know if we're gonna get to hair. After Zig, I'll need to switch to something. I don't know. We'll see where the wind takes us. But for now, we were looking at the end where we had a little bit more in the learn section that guided us to the book, right? What was the guides, introduction? Project-based book. There we go. That's the one. This one. And okay, so we went through introducing Zig, control flow, structs, modules, and types. I guess that's where we need to start, right? Because we went all over to chapter 1, what is Zig, and all that stuff, and we ended up with how strings work, safety, and other parts of Zig. And this was basically an overview that there are a lot more things to go with. So we'll finally start getting control flow. Tess says, good luck. My mind is so ducked that I am barely existing. Oh, I'm sorry to hear that. Hopefully, good night's sleep is going to reset your brain. This is the time of day where mine works the best. Or close to it. All right, control flow and all that stuff. So finally, we'll start actually programming maybe, or learning something. Actually, can't wait to get through more of the Ziglinks exercises. Okay, so let's get going. Okay, that border is from the browser. Yeah, I hate that border around it. It's so wasteful. Control flow, structs, modules, and types. Wow, there will be a lot in this chapter. Because control flow, yes, structs, I guess that will be the most basic way to structure our data into other than normal variables and whatnot that we learned initially. And we'll go straight up into modules, I guess, to, work with more than one files, and types. Okay. We have discussed a lot of Zig's syntax in the last chapter, especially in section 1.22 and section 123. And what was in that? The main Zig file? Yeah, so that's where we learned about this and the root Zig file. Okay. But we still need to discuss some other very important elements of the language. Elements that you will use constantly on your day-to-day routine. We begin this chapter by discussing the different keywords and structures in Zig related to control flow, for example, loops and if statements. Then we talk about structs and how they can be used to do some basic object-oriented patterns in Zig. Okay. We also talk about type inference and typecasting. Finally, we end this chapter by discussing modules and how they relate to structs. All right. So, control flow. Sometimes you need to make decisions in your program. Maybe you need to decide whether or not to execute a specific piece of code, or maybe you need to apply the same operation over a sequence of values. These kinds of tasks involve using structures that are capable of changing the control flow of our program. In computer science, the term control flow usually refers to the order in which expressions or commands are evaluated in a given language or program. But this term is also used to refer to structures that are capable of changing this evaluation order of the commands executed by a given language or program. Okay, these structures are better known as set of terms such as loops, if-else, statements, switch statements, among others. Okay. So loops and if-else statements are examples of structures that can change the control flow of our program. The keywords continue and break are also examples of symbols that can change the order of evaluations, since they can move our program to the next iteration of a loop or make the loop stop completely. Exactly. So, we control the flow of the program this way. So we start with if-else statements. Beautiful. If an if-else statement performs a conditional flow operation. A conditional flow control or choice control allows you to execute or ignore a certain block of commands based on a logical condition. Many programmers and computer science professionals also use the term branching in this case. Yep. In essence, an if-else statement allows us to use a result of a logical test to decide whether or not to execute a given block of commands. In Zig, we write if-else statements by using the keywords if and else. We start with the if keyword, followed by a logical test inside a pair of parentheses, followed by a pair of curly braces, which contains the lines of code to be executed in case the logical test returns the value true. Okay, so sounds very, very, very standard. After that, you can optionally add the else statement. To do that, just add the else keyword followed by a pair of curly braces with the lines of code to be executed in case the logical test defined at if returns false. In the example below, we are testing if the object x contains a number that is greater than 10. Judging by the output printed to the console, we know that this logical test returned false because the output in the console is compatible with the line of code present in the else branch of the if-else statement. Okay, so we have constant x, that is 5. So if x, so we have, this is like very, very, very standard, right? Normal parentheses for the condition and curly braces to enclose that, and we have just lonely else with all this stuff. And I guess the expected syntax is that we write else in the same line after the brace closes. All right. So a condition if x is larger than 10, right? These all seem to be just, what do you call it? A constant, like comp time integers. And if yes, I guess this is again the old way to do it. We just print, and that's it. So here result was x is less than 10, less or equal 10. Okay. So we went this test, of course, 5 is not larger and whatnot. So wow, that's all we get for the if statement. We just jump to switch statement. Okay, I like it. We're moving fast. Wow, we're just going to run through those, huh? Switch statements are also available in Zig, and they have a very similar syntax to a switch statement in Rust. And as you would expect to write a switch statement in Zig, we use the switch keyword. We provide a value that we want to switch over inside a pair of parentheses. Then we list the possible combinations of branches inside a pair of curly braces. All right. So just a sneak peek, switch over the roll, and we do a bunch of stuff, right? Arrow something, arrow something, arrow something. All right. So let's take a look at the code example below. You can see that I'm creating an enum type called roll. We talk more about enums in section 7.6, but in summary, this role type is listing different types of roles in a fictitious company, like SE for software engineer, DE for data engineer, and PM for product manager. So let's take a peek at enums. Exciting. So yeah, we import standard stuff so that we have a writer, and then we have constant role. Huh. So we create constant variable called role and enum with that, okay? Whatever DP is. Whatever, don't matter, but okay. So I wonder if that will be with all types, where types are defined just like variables, but just have type. Hmm. And then, all right, and then we have a function, main function that can return an error, as far as I understand, and therefore we create variable area. Why is a variable if the value is constant U8? That's confusing. Oh, because it's an array of constants? That's what it is? Wait. This thing was strings, right? So it's a string, I guess. So area as a string that's initially undefined. Then we have our role, right? We specify it to be software engineer, and we'll switch over the role. And if it's this, area is platform. If it's this, area is data analytics. And if this, it's sales. And then we can print it out, right? Okay, so it makes sense. Notice that we are using the value from the role object in a switch statement to discover which exact area we need to store in an area variable object. Yeah, so this is the role. We create a specific role, yeah, and then we just run over it, and I guess depending on its type, from here it knows what to do. Okay. Also notice that we are using, that we're using type inference inside the switch statement with the dot character, as we are going to describe in section 2.4. This makes the Zig compiler infer the correct data type of the values PM, SE, etc. for us. Yep, we don't need to specify anything that, hey, this is a role or anything past it. Perfect. Also notice that we are grouping multiple values in the same branch of the switch statement. Yep, multiple of them here, just comma separated. And they are .pm, .se, .dpe. Huh, that's a different syntax. We just separate each possible value with a comma. For example, if role contains either DE or DA, the area variable would contain value data and analytics instead of platform or sales. Yep. So this is interesting with the .pm and .se. Huh. Because normally one would expect that it would be just PM, SE. Inferred from the role, right? But I wonder if the dot is there to just make it explicit that this is something from here, right? From here, .pm. Not just random PM that could be defined elsewhere, I think. I mean, it makes sense. It's readable. Okay, so switch statements must exhaust all possibilities. One very important aspect about switch statements in Zig is that they must exhaust all existing possibilities. In other words, all possible values that could be found inside the role object must be explicitly handled in this switch statement. Since the role object has type role, the only possible values to be found inside this object are PM, SE, and whatnot. There are no other possible values to be stored in this role object. Thus, the switch statement must have a combination, as in branch, for each one of these values. This is what exhaust all existing possibilities means. The switch statement covers every possible case. I guess we will also be able to put like a wildcard, like an underscore or something, to make it happy. Therefore, you cannot write a switch statement in Zig and leave an edge case with no explicit action to be taken. This is a similar behavior to switch statements in Rust, which also have to handle all possible cases. So maybe we could test that. I would love to test that. So let's just switch to the other screen, and I think I said something. Test/Zig, right? No. Oh, temp/Zig. And here we had Ziglings, in which we had exercises. in which we had our 000, right? Yeah, so let's just do code here. We're just gonna go VS Code and call it a day. There we go. We even have last runs here that won't be remembered. Zig run. There we go. We'll be able to copy this one. Okay, so we had some stuff that we're playing with last time, right? We were trying hard to make some pointer magic that I 100% don't remember anymore. So let me just paste this here and we can grab this code. Oh, we will need to do some other magic with printing, right? std standard debug print. That's what we need. Okay. So we don't need the standard out. We'll have our role here. And instead of this, std debug print. There we go. So let's just make sure this runs. Expected error, enum type found void. Oh no. Oh, that's right, because we don't need to try. Therefore, we don't need to specify error here because it will be complaining about us as well. And now it goes. Okay, it says platform. So I guess the moment I will remove the, let's say, SE from here, or let's say maybe something that hasn't been used, the DPE, right? I'm gonna save it and try to run it. We get, oh no, switch must handle all possibilities and unhandled enumeration, and it tells us that DPE is not handled. Okay, is it possible to do something like underscore and area is whatever? Is it possible? It's not complaining about the syntax. Let's run it. No, underscore prong. Only allowed when switching a non-exhaustive enum switch. Dot underscore? Nope. No field name underscore enum. Interesting. So non-exhaustive. Only allowed when switching a non-exhaustive enums. Excuse me, switch role. Okay, so maybe there's other way to do it. We don't know about it yet. We just have an overview, right? So we can just skip it the easy route. I wonder if it's because, you know, the moment we start editing this, right, adding more, this would just catch all and would make things prone to be erroneous instead of just working. But what if you have an enum that has 200 of those and you only care about 2 or something? So, yeah. Don't know at this point. But at least we figured out that you can't just do underscore and call it a day. All right? Okay. Alrighty. The else branch. Take a look at the dump hex fallible function below as an example. This function comes from the Zig standard library, more precisely from the debug Zig module. There are multiple lines in this function, but I omitted them to focus solely on the switch statement found in this function. Notice that this switch statement has 4 possible cases, as in 4 explicit branches. Also notice that we use the else branch in this case. Oh, we just do else. I mean, we're switching over a byte, right? I guess we're going over all the bytes. So switch over a byte. We do single quotes to like define a single letter instead of a string. And we do a bunch of stuff. All right. So can I do just else? Right? Else arrow something. Will that solve our problem? Yeah, it works. Okay. So if I would also remove the software engineer, it would just say whatever, right? Yep, it ran through our error branch. I mean, else branch. Okay. So we learned that quickly. I didn't even need to test it. It was right next to the next paragraph. As per usual. Okay. So this is nice. We also have an example that we can do the same over the bytes. Syntax doesn't change. So many programmers would also use an else branch to handle a not supported case. That is a case that cannot be properly handled by your code, or just a case that should not be fixed. Therefore, you can use an else branch to panic or raise an error in your program to stop the current execution. Take the code example below. We can see that we are handling the cases for the level object, being either 1, 2, or 3. All other possible cases are not supported by default. And as consequence, we raise a runtime error in such cases through the panic built-in function. Okay, so we have our level that normally has number 4, which is, I guess, invalid, right? So we basically do the switch over level, but oh, look at that. We have assignment here. We have a they sneaked in the switch expression rather than the statement. I'd call it. That's how many languages call it. So yeah, the category is, and we switch over the level, right? And for option 1 and 2, we just return beginner. We don't run any code. We're not doing like, hey, try to write something or print something. No return or anything. Just the word beginner that's gonna be assigned a category. So it's awesome to see in a low-level language to have nice syntax, because this just saves so much typing and reading at the same time. So that's awesome. We have handle 3, but everything else is literally panic, not supported level. Beautiful. So in other words, I could do here for else. So this is area is this and that. So in theory, I could say var area of the type const u8 is, and we commented out here, switch role on this, and instead of area is this or whatever, we can probably simplify it drastically by saying, hey, if it's this, do that. If it's that, it's that, and whatnot. And do we need like just commas? Okay, so let's do comma. We need to get rid of those here. And for else statement, we'll just do panic. Oopsie. And that's it, I guess. That comma is left over here, and this should end because this is an single statement now, I guess, right? They have it here, and they end that with a comma because it's optional, but you can have it there. Okay, let's try. Error expected this after the statement. Oopsie. Oh, exactly in here. And now area is local variable is never mutated. Oh, so we can make it a constant. Huh. Yeah, this one had a concept of constant, right? That means that this whole code is running during compilation, I guess. I guess Zig will just magically make it, hey, everything's constant. I'm gonna run it during compilation time. So we have here, thread this panic. And did we even execute it? I don't know. Let's see. If we're gonna do, instead of run, build. Member function expected 5 arguments, found 3. Okay, so the build didn't work, right? We have the run, because for some reason build, I guess, tries to build it from somewhere else. So we can't do that, but I don't know if this is during build time or not. I don't know. I guess it would be safe to assume that it's not during build time, but I'm sure we can execute switch statements during build time, right? That must be normal. It's Zig after all. All right. So okay, so we also learned about panic and about switch expressions rather than just statements. So that's very exciting. Oh, this is going fast. Using ranges in switch. Furthermore, you can also use ranges and values in switch statements. That is, you can create a branch in your switch statement that is used whenever the input value is within the specified range. These range expressions are created with the operator ... It's important to emphasize that the ranges created by this operator are inclusive in both ends. Oh, thank you. Thank you that they are inclusive on both ends. That makes it actually nice and clear and readable. For example, I could easily change the previous code example to support all levels between 0 and 100, like this. Yep, so we have level and whatever. And we just changed it from 0 to 25, including the 0 and including the 25. We go beginner. From 26 to 75 is this, from this to that is professional, and everything else is like, oops. Yep, beautiful. I'm really excited about this. Suddenly makes me want to make games in Zig because we can pack things together. It's kind of fun so far. Yeah, I'm liking it. This is neat, and it works with character ranges too. That is, I could simply write from A to Z to match any character value that is lowercase letter, and it would work fine. Oh, this would also make writing all the various, what do you call them? Like, whatever, various parsers and whatnot, probably fun to some extent. I mean, it wouldn't take away anything difficult. It would just make things a little bit more readable, which is nice. All right. Would it work for enums though? Because can we do like from SE to PO? Or let's do from SE to DA. And that's from .se .pm. Doesn't complain. We just have 4 dots, which is kind of unfortunate. Here we would make it to be, let's say, just PO. This would be just KS. Yep, and else is kind of not needed here. But what's going to happen? No, ranges are not allowed when switching on type role. Okay, so I guess for enums we can't do roles unless we will maybe define some kind of different enum. Who knows? But oh, look at that! Now we actually have type stuff. So I guess our LSP started working. Good. Okay, nonetheless, very exciting. Labeled switch statements. Ooh, in section 1.7 we have talked about labeling blocks and also about using these labels to return a value from the block. Well, from version 0.14 and onwards of the Zig compiler, you can also apply labels over switch statements, which makes it possible to almost implement a C go-to-like pattern. For example, if you give the label XSW to a switch statement, you can use this label in conjunction with the continue keyword to go back to the beginning of the switch statement. In the example below, the execution goes back to the beginning of the switch statement 2 times before ending the 3rd branch. Okay, so we labeled it XSW, and we have our switch statement, and here we have this weird syntax. I guess we're trying to convert 1 to a U8. As in, okay. All right. And basically, if it's 1, oh, because we want to make it more exhaustive or something? I don't know. But I guess if we would just type in 1, it wouldn't be of an integer type. It would be probably just the compile time, the comp time integer, which would mean that we can't change anything. Don't know. But let's see. So on a branch for 1, what we start with, we do, okay, first branch, right? We print that, continue, XSW, and we can provide a value. Oh, really? Huh. That's kind of fun. What a strange concept. And we can just provide a value 3. Why not? We're not reading a variable or anything. We just throw in a value. Okay. Yeah. Here we just return on 4. Nothing happens. So I guess we also return. And then we have else, unmatched case, blah, blah, blah. Okay, this is kind of fun. I must say that it's interesting because we could have such various logic types that kind of switch between blocks of code. I wonder if this could be used in some extent to do maybe some kind of state machine or whatnot. And that could kind of make it really easy to do that. I don't know. Interesting concept. All right, the defer keyword. Zig has a defer keyword, which is so much fun, which plays a very important role in control flow and also in releasing resources. In summary, the defer keyword allows you to register an expression to be executed when you exit the current scope. When you exit the current scope. Awesome. That means that we can make like subscopes and whatever, various blocks, and decide when it happens. At this point, you might attempt to compare the Zig defer keyword to its sibling in the Go language, because Go also has defer keyword. However, in Go, defer keyword behaves slightly different than its sibling in Zig. More specifically, the defer keyword in Go always move an expression to be executed at the exit of the current function. Oh, so not scope, just the exit of the current function. If you think deeply about the statement, you will notice that the exit of the current function is something slightly different than the exit of the current scope. So just be careful when comparing the two keywords together. A single function in Zig might contain many different scopes inside of it, and therefore, the defer input expression might be executed at different places of the function, depending on which scope you are currently in. So I want to already try it. So, well, this is not a good example, but maybe we could borrow this one here, right? Let's try to use this one. We'll just plop it here, all right? And instead of this whole try standard out print, will be just std.debug print, okay? This should make it work. We can get rid of the enum that we're not using. And what is going to happen? I expect we start with first branch, then we go to the second, which will move us to third, which will return, and that's it. First branch. That's what we should see. First branch, there we go. So I guess what we could do is, in here, we could basically say, let's say we have var name is, I guess is whatever. We're gonna say Ben, okay? We're gonna do that here. The name is Ben. And first branch is this name, and we just do, what was it? S for string, and we're just gonna put name in here, okay? And now it complains because it's never mutated. So let's throw in defer. Name is I know, not Ben. And therefore looks like it might compile. And so what I would expect is that by this will just move it all the way to here, right? So maybe we can actually do something more fun. Let's actually define it in the beginning, that we have the name Ben, all right? And then throughout the first thing, we're gonna say not Ben. Maybe throughout the second thing, instead of just continuing, we're gonna set it to something else, like maybe will be totally someone else. And we're gonna print it out here that we are second branch, okay? And we can also defer it to change from band to Wololo somewhere else, like here. There we go. This will be this. And we're gonna also do the third branch the same way. Okay. Instead of continue, we're just gonna have return. And we'll name the defer name to, I don't know, umbrella. Why not? And this will be third branch. And after the third branch, we're just gonna say that if this is a switch statement here, we'll just after that gonna throw in after switch, and we print out the name, and we can even throw in one before the switch. Before switch. So before we run it, I want to kind of figure out if it's going to be exactly what I think it's going to be. So what I'm expecting is that, first, of course, our name here is Ben. This will defer the change of a name until we exit this whole scope, which is by the time we exit main, then it's going to be changed to Wololo. So at this point where this is running, it should just say Ben. Then it goes to the first statement. We defer the name to be not Ben, but here it should still say Ben. We go continue, therefore we exit the scope and only then we change the name to not Ben. So by the time we get to 2, we have another defer in progress, but here we'll print not Ben. And the same thing here will print the totally someone else from the previous branch. And set umbrella here. So by the time we get here, this should say umbrella. And Wololo will be never printed because Wololo will be set only when we actually exit this main function, which is, you know, our program exited. So let's try to run it. Please run. No, expected type constant of this. Okay, so here we have predefined the length of it. So maybe we can say that we don't predefine the length. Constant of U8. Will that work, please? Yes. Okay, so before switch we have ban, first branch is ban, then we have the not ban, then totally someone else. And our after switch. Didn't work. Because returns entire function. So we would need to do break. No. Break expression outside loop. We do nothing. I don't know if nothing, I guess, won't make it go to the next step, right? Let's try it. Okay, it went just doing nothing. Didn't make it unmatched thing, so it just went to after switch. Okay. And that's where we printed umbrella because at the end here we deferred at the end of 3. We just need to do that. Okay, beautiful. We have something that works. So what if I'm going to do this? Instead of defer here, we're going to create our own extra block. We're going to start it here. It will encompass everything all the way to including this statement and end here. And then we're going to throw in one more statement behind. So it'll be total end. So that means that we have the ban available here. We deferred this to be at the end of this. Therefore, by the time we're going to get here, we should see Wololo. There we go. It worked. So that's the fun part. You can create your own scopes wherever you want just to kind of execute some code after it, and doesn't matter if I'm suddenly gonna throw in return here, that still will run because of stuff. And I expect that if we were to do return here, it will first run this code because we exited this statement. And then it would run this code because we exited the whole thing. Yeah. So that kind of would do things in order. That's what sounds, let's say, that's what I would expect, basically. Okay, this is super awesome. So we know that it's not letting go. Basically, we can go at the end of the current scope. So we went to that. Okay. As a first example, consider the foo function exposed below. When we execute this foo function, the expression that prints the message exiting function is getting executed only when the function exists in scope. So we have our standard whatnot function foo defer. So we defer this to be at the end of this whole thing, right? Which should then print exiting function. Okay. So when we execute this foo function, the expression that prints the message exiting function is getting executed only when the function exits its scope. Yeah, at the end. So when we run this, it's try foo, right? So we enter here, we defer to the end, we print adding some numbers, multiplying, and then we exit. So we're gonna print exiting function. Bam, bam, bam. Beautiful. And the nice thing about this defer is that no matter where in what branches we are, the moment we actually exit the function, it's always going to execute. So it's like a guarantee. So that's awesome. It's, normally to get something like that, you would need to either throw this thing in multiple places or wrap this function with some other one to put some stuff after it. Yeah. Therefore, we can use defer to declare an expression that is going to be executed when your code exits the current scope. Some programmers like to interpret the phrase exit of the current scope as the end of the current scope, but this interpretation might not be entirely correct, depending on what you consider as the end of the current scope. Yeah. I mean, what do you consider it as the end of the current scope? Is it the closing curly bracket of the scope? Is it when the last expression of the function gets executed? Is it when the function returns the previous scope, etc.? For example, it would not be correct to interpret the exit of the current scope as the closing curly bracket of the scope, because the function might exit from an earlier position than this closing curly bracket, of course. For example, an error value has generated at a previous line inside the function. The function reached an earlier return statement, etc. Anyway, just be careful with this interpretation. Exactly. Basically, the moment we exit this scope, no matter through what means, when the scope, I don't know what the name here is, collapses, when we exit it, only then we run it. And many things could cause it to do something. The thing is that I guess with the go defer would be that somewhere more deeply nested, we could have a situation where we have maybe if else defer something, and therefore we would guarantee that we can add something to the end of it, the entire function, rather than that little subscope of the if statement. So I guess that's the difference. So we can kind of gain some power with this from Zig, and lose some of the ghost power, and go at the same time has its own power of, hi, I can just throw stuff at the end of the function, but we can't have them like per scope or whatever. So at the end of the day, maybe the Go version is a little bit more powerful because you can always keep wrapping things in functions, while this sounds a bit more difficult. Although you could kind of go around by specifying some parameters or something. Who knows? Probably from day to day, this will be more powerful, like more useful. And for sure, easier to kind of comprehend. Okay. There we go. Now, if you remember of what we have discussed in section 1.7, there are multiple structures in a language that create their own separate scopes. For while loops, if-else statements, functions, normal blocks, etc. This also affects the interpretation of defer. For example, if you use defer inside a for loop, then given given expression will be executed every time the specific for loop exits its own scope, as in per iteration, right? Before we continue, it's worth emphasizing that the defer keyword is an unconditional defer, which means that the given expression will be executed no matter how the code exits the current scope. For example, your code might exit current scope because of an error value being generated, or because of a return statement, or a break statement, etc. What about panic? Didn't we have an example of panics at some point? What if we will just do defer instead of name? We'll go defer standard debug print whatever, third branch, okay? That's what we're gonna defer. Another thing is, does it capture this? Oh, so many questions. I'll need to test that in a second. Yeah, I will definitely need to test that. So we'll just do third branch this. We defer the other one. What happens when we do panic? Fake oopsie. And Nokiam says, if you look at the panic handler function, the return type is actually no return. So it does not return from the function. Ooh. No return. Oh, that's fun. No return. Invokes the panic handler function. By default, the panic handler function called the public panic function exposed in the source file. Or if there's not one specified, some built-in whatever. Generally, it is better to use import standard debug panic. However, panic can be used for two scenarios. From library code calling the programmer's panic function if they expose one of the root source file when mixing C and Zig code. Oh, so it will be fun to use the other one. So I'm assuming panic will just go crazy and stop the whole program. That's how I would understand it, right? So we have first, second, third branch, right? And then we have our fake oopsie and core dumped and just stopped completely. Okay. So this will mean that we don't do the first stuff. Okay. So I guess one would need to be careful when they panic. Don't always just panic, because what if you started some expensive operation that maybe it doesn't matter that your process ends, it still keeps going, right? Maybe you started completely separate process or whatever. You would prefer to actually close it before panic, because if you panic, it just keeps going or whatever. So that's interesting. And I guess standard debug panic will be exactly the same thing. Oh. Yeah. Name this. We have our fake oopsie. Wait, this is a good one, right? Two arguments. What does it expect? Format and then arguments. Oh, it's like print. So we throw in a new line and we just do empty and save and clear this and run. Yeah, panic, 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 and don't return anything. Okay, thank you for the tip, Nokiam. So now that we have that covered, I want to kind of figure out how passing values would work. Because let's make like a little more simple example. Instead of this whole switch statement, we don't need it anymore. Instead of having this nested stuff here, we don't need that either. We're going to make a very, very simple example. We're gonna give it still a name, okay? Ben or whatever. And let's do defer. Sure, we're going to straight up defer it to be walala. And then we're going to have that print statement. We'll say just hello name, okay? I should be able to run this no problem. This is kind of pointless, but sure. Let's see if it runs. Okay, it says hello Ben. So now, what if I'm going to do defer, okay? And I'm going to defer printing the name. I guess printing expects this to be, I don't know, any type? I guess this defer will run first and this defer will run later. So it should say hello Ben. Right? No. It went the other way around. So it said hello. So I guess maybe the later defer gets deferred first and then we do that. Just like we kind of destroy scopes in the other order that then they were created. So if I do this, maybe we'll run this one first. We'll say Ben, and then it will say walala. Yeah. Huh. Okay, so we learned that the first statements are being called in a backwards order. And we learned that this here doesn't capture the variable itself, like its value straight away. It will just fetch it whenever we're running it, whenever the first statement will be actually executed. Therefore, this was changed, and after that we're running this one, and that causes it to run this thing. All right, okay, that's a good thing to know. And there's a chance that they will explain exactly that right after I go back to reading, okay? All right. So for multiple structures, create their own separate scopes. Yeah, that's how it works for loops. So we'll need to try it to run it in a loop to see if it's for an entire loop or if it's just for an iteration, because I expect the defer will be per iteration. All right. Before we continue, it's worth emphasizing that defer keyword is an unconditional defer. Yep. However it works. If it breaks statement or return statement or whatnot, it will always run it unless it's panic. Panic is like the ultimate. You're not gonna run a single line of code after that. All right, so the error defer keyword. On the previous section, we have discussed the defer keyword, which you can use to register an expression to be executed at the exit of the current scope. But this keyword has a brother, which is the error defer keyword. While defer is an unconditional defer, the error defer keyword is a conditional defer, which means that the given expression is executed only when you exit the current scope in a very specific circumstance. In more details, the expression given to error defer is executed only when an error occurs in the current scope. Therefore, if the function or for while loop, if else statement, etc. exits the current scope in a normal situation without errors, the expression given to error defer is not executed. This makes the error defer keyword one of the many tools available in Zig for error handling. In this section, we are more concerned with the control flow aspect around error defer, but we are going to discuss error defer later as an error handling tool in section 10.2.4, which is 10 years from now, okay? So the code example below demonstrates three things. All right, so I can already see that we have those two. What the hell is going upstairs? I guess my cats are going crazy. Bunch of noises. So the code below demonstrates that defer is an unconditional defer because the given expression gets executed regardless of how the function foo exits its own scope. And that error defer is executed because the function foo returns an error value and that defer and error defer expressions are executed in a LIFO, last in, first out order. Exactly. So that's what we discovered so far, and I guess just applies to any kind of defer. So we have function foo, okay, that will return error, just like that, just throw an error. Or no, it actually does return the error. Oh, that's interesting. Huh. So we don't throw an error, we just return it. Does it mean that in Zig we can't throw rocks like we could in Dart? We can just return them? Okay. Interesting. So function main void. We have some use size and whatever, some 1, okay. String debug print value of this, so that we deferred. Oh, that will be only if we have an error, right? Debug print value of I, bam. We then have defer as 2, and we try foo with this throws error, right? So I guess this try basic tries to run it, and if it gets an error, it's going to return it to something or pass it over. I don't know how it works. We'll learn about it later. But then we get to the point where we go do the first. So we start with the last one first. So it will be, I will be switched to 2. And then we got this one, and this one checks if it's an error. In this case, yes, we've got an error. We're going to print that. So value of I is 2. An error is whatever, right? When I say that defer expressions are executed in a LIFO order, what I want to say is that the last defer or error defer expression in the code are the first ones to be executed. You could also interpret this as defer expressions are executed from bottom to top or from last to first. Yep. Therefore, if I change the order of the defer and error defer expressions, you will notice that the value of I that gets printed to the console changes to 1. This doesn't mean that the defer expression was not executed in this case. This actually means that the defer expression was executed only after the error defer expression. The code example below demonstrates this. So it's exactly the same thing. We just swap those. So therefore, this exits. We have an error at the point we exit function. And okay, this one is the first from the bottom. So we print this, it'll print 1. And then we change it, and then we just delete it because this is out of scope. Okay, perfect. It returns 1. Alrighty, so that's nice. That's it's very interesting how the order of things, because normally you learn first if else, then you learn for or while loops, and then you learn the fun stuff like switch. Here just went briefly over if else, fun with switch statement, fun with the first statement. This is cool. All right, so let's go loops. Maybe we'll have some fun unexpected stuff here as well. Hopefully, although I don't expect that really. For loops, a loop allows you to execute the same lines of code multiple times, thus creating a repetition space in the execution flow of your program. Loops are particularly useful when we want to replicate the same function or the same set of commands over different inputs. There are different types of loops available in Zig, but the most essential of them all is probably the for loop. A for loop is used to apply the same piece of code over the elements of a slice or an array. So for loops in Zig, use a syntax that may be unfamiliar. For loops in Zig, use a syntax that may be unfamiliar to programmers coming from other languages. You start with a for keyword, then you list the items that you want to iterate over inside a pair of parentheses. Then inside a pair of pipes, you should declare an identifier that will serve as your iterator or the repetition index of the loop. Okay, I mean, that makes sense, right? So for items, right? For something. And this is kind of, I don't know why this kind of reminds me like a capture group. I don't know why, where it's coming from, that idea. But yeah, okay, so this is our index, right? So instead of for value in items, you have for items, and this is like, I don't know, I kind of like it because it's a little bit more explicit, that like separated what we're iterating over and what is the value we have available within the loop. So yeah, okay. Therefore, instead of using a value in items syntax in Zig, for loops use the items value. In the example below, you can see that we are looping through the items of the array stored in the object name and printing to the console the decimal representation of each character in this array. Alrighty. If we wanted, we could also iterate through a slice or a portion of the array, instead of iterating through the entire array stored in the name object. Just use the range selector to select the section you want. For example, I could provide the expression name from 0 to 3 to the loop to iterate just through the first 3 elements of the array. So we have our name, right, which is Pedro. And we iterate over the elements of the name, and we just extract the character, right? CPN says, hi, hello to you, CPN. It's good to see you. Welcome back. How are you doing? And then we just print out the character as a decimal. All right, so that's simple. I like that. And example would be to just modify it slightly, right? So we can probably just modify what we have here, right? So let's ignore the first statements and whatnot. We're just going to do for name. And we say, let's do Benjamin. And from the 0 to 1, 2, 3, because this, I believe, doesn't include the 3. That's what I remember it. And this will be the character, right? And we can do stuff with that. And right now it's unhappy that we're not doing anything with it. So we're just gonna, I guess, print it one by one. So we'll just do that. This will be the decimal of it. We'll do nice space afterwards. And this will be the not name, but character. And yeah, let's run it. Why did I do under $sign here? What the heck? Yeah, 3 letters, 1, 2, 3. Perfect. And CPN says I'm doing good. Awesome, good to hear that. I'm happy to learn more of Zig. The first statement is awesome. I'm very happy to see it. I see that, we made a test a moment ago with the, where is it? Bum, 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 bum. Come on, so many Control Z's. There we go. Oh no, this is not even that. Never mind. I must have passed it. But yeah, the first statements and how they execute backwards and all that stuff. How they don't capture the values, they just executed whatever. It's fun. Alrighty. So in the above example, we are using the value itself for each element in the array as our iterator. But there are many situations where we need to use an index instead of the actual values of the items. You can do that by providing a second set of items to iterate over. More precisely, you provide the range selector to the for loop. So yes, you can use 2 different iterators at the same time in a loop in Zig. So I guess we'll see it in here for a second. But remember from section 1 before that every object you create in Zig must be used in some way. So if you declare 2 iterators in your for loop, you must use both iterators inside the for loop body. But if you want to use just the index iterator and not use the value iterator, then you can discard the value iterator by matching the value items to the underscore character, like in the example below. Okay, so we have the same name Pedro for name, and from 0 to whatever I guess this is, it's gonna magically match that the last number is the number of characters in the name. And then we discard the specific character and we just print the index. All right, that's awesome. And that will be printing the index. So let's do something like that. It's just like, in a little bit silly, pointless way. So I guess let's move as, there we go. So, and Span says you can do defer code block. Yep, gives the index. Yep. And NoCam says you can have any amount of iterators if they all have the same range. Awesome. Yep, so this way you can like zip stuff and whatnot. That is handy. I wonder to what extent Zig actually, what do you call it, optimizes it. Because one would want like, oh, I'm just gonna do index and extract stuff in a way. I wonder if Zig, a compiler, is actually able to compile, optimize it more than your manual code, because this is kind of more explicit, and this way compiler has, okay, these are a little bit more strict rules. I can assume more in this situation, therefore optimize it even more. Interesting. So I'm gonna do 0 ... and now it's complaining that I'm not using it. So we're gonna throw in that this is gonna be index, right? Now it's not complaining. I can say that, hey, I'm not using the character. I'm just using the left side just so that I iterate over everything correctly without knowing, calculating myself how many items I need. And we're gonna do that, not character. We're gonna do name index, right? That's how we're gonna get the character. And second one will be the index. Or let's actually do it the other way around. We're gonna first get the index and then do that. So we're gonna do this and that, and we're gonna wrap it in this nicely so that we're gonna have a little bit prettier thing. So that should print 0, B. Sorry, yeah, 0 and the number. And then will be, oh, no. Yeah, the number. Yep. So let's actually do the third one. This will be, how do you do character? Just string? I'm confused. I don't know how to print a single character. So I would just say that this will be this twice. How about that? I want to see what happens. Now in valid format S for type U8. How do I print a single character as a actual character? C? I'm totally guessing now. Yeah, there we go. See. So 0 is B, which is number 66. 1 is E, which is value 101, and 2 is N, which is 10110. Okay, there we go. Worked out. And CPN is already helpful with C. And Nokia also says the index can also start from any value, 0 or 1, etc. Oh, so we can basically say that I'm gonna pretend that this starts from value 30, and therefore we'll be counting up, but just the correct number of stuff, right? Oh, but I'm using a wrong index here, so it'll be like, no, you're doing something wrong, of course. Yeah, but this is fun. I like that. Could I do something crazy like? So I guess I could even make it. I want to try something different. What if I want to print out all the like consecutive 3-letter, like, I don't know, n-grams or something? I don't know what they're called. Band and ENI and IA and all that stuff, right? So what if I'm going to do, yeah, 4. We do name, we do 0 to 3. Okay, then we're gonna do, oh no, because we would need to iterate over it differently. So maybe not, but I can do name 03, then we're gonna do name 1, 2, 4, and maybe one more, which will be 2, 5. And we're gonna capture whatever, we'll call it C1, C2, C3, right? And this way I'll just gonna print them in this simple fashion of C, C, and C, and space. And this way we're just gonna do C1, C2, C3. And something is unhappy there because I have fur. I'm thinking of trees rather than loops. There we go. Let's just comment this out and this one as well and see if we actually gonna get. It should be Ben, ENI, and NIA. That should be the result. Okay, we can do that. That's kind of fun. Yeah, no need to use indexes or whatever. It just go for it. Cool. Yeah, this will be fun when you have multiple things and you need to kind of zip them together. All right. The two iterators, we need to use them up, or we can use the wildcard to discard it, or whatever they call it. What do they call it properly? To the underscore category. Oh, so they don't call it. I guess just wildcard. That's what I would call it. Alrighty. So that's it when it comes to for loops. But we were supposed to try defer inside of here. So if I'm going to do defer, and it'll be standard debug print deferring loop number, and we're gonna throw it in here, and we're just gonna say this will be index. Okay, and magically we can just throw in, hey, from 1 to something. We'll make it 1 based. We'll call it index, and we just use it here, and magically we have deferred. So what I'm assuming is that this defer statement will print every time, every loop iteration, right? Instead of just once for entire thing in the end. That's how I would expect it. Then deferring loop 1. ENI deferring loop 2. Yep, exactly. Perfect. That worked. And it was super easy to do as well. I really like this counting because I could start at, hey, I'm pretending that this is so many loops. So it'll be 1000, 1001, and 1002. Perfect. Oh, this is so nice. This is so nice. And Sibian says, we don't use fancy name. By the way, you can omit the D when printing int. Okay. All right. Yep, makes sense. I use fancy names. I want my code to be readable. Compiler strips it away anyway. These are disgusting, but in this case, just work. It's an example. Otherwise, I'm always gonna try to make my code readable. Alrighty. While loops. A while loop is created from a while keyword. A for loop iterates through the items of an array, but a while loop will loop continuously on and infinitely until a logical test specified by you becomes false. So you start the while keyword. You start with the while keyword, then you define a logical expression inside a pair of parentheses, and the body of the loop is provided inside a pair of curly braces, like an example below. Yep, so very standard while something, and we have curly braces, what something happens. In this case, we basically, besides printing, we actually keep increasing the I. So the moment it reaches 4, after 4, it will just stop. So it will reach 5, but by the time it reaches 5, it just won't execute the block. So it will be basically print it out from 1 to 4. So we'll have 4 things, right? There you go, 4. You can also specify the increment expression to be used at the beginning of a while loop. To do that, we write the increment expression inside a pair of parentheses after the colon character. The code example below demonstrates this other pattern. Oh, this is interesting. So, so this will run after, right? Yes, because it doesn't increase the first time. So this is going to be running after, and therefore we don't have to do that here. Okay, so that makes sense if you always, whatever, do something here, right? If you don't have any special logic to when to increase it, how many to increase it over, and whatnot. I kind of like it because, I mean, I don't know how often there are errors with while loops. At the moment, you start getting relatively careful with them, you don't have any problems. But I guess this could solve a number of problems where you're doing the simple iteration from 2. So this is like a classic for loop at this point. The only thing that this is outside of it. But you could do it over range, which will be even nicer. But yeah, you just do this thing. And therefore, yeah, it's a little bit explicit that you're not going to forget to not include it or something. The other option will be to probably, in the beginning, just use defer to just increase it, which could be fun. So let's say that we have a very simple thing, all right? We're going to say, we don't need even a name. We're just going to var I is 0. We just need to specify that it's, let's say, U32, right? While I is less than 1000, what we're going to do is basically do standard debug print, and we're going to just print a dot. All right, that's all. I guess we still need this random thing at the end. There we go. Wonder how that is being defined, because I kind of am curious what kind of construct this is. All right, so we've got this part. And if we're gonna run that right now, it will be very unhappy. It will just run forever. So normally one would go, okay, now at this point, I'm gonna increase the I plus equals 1, right? Let's just make maybe and actually print the I. This way we kind of have something here. So let's run it. Bam. And we've got all the way to 999. Beautiful. Incipient says the dot and curly braces is a tuple. All right. Okay, so we've got tuples. That's fun. Alrighty, so this works as I would expect. So another thing would be, we wouldn't do that because this will increase the first instance, and therefore we would start not from 0, we would start from 1, right? We run it and we go over to 1000 because we started from 1. Okay, so we don't want that, but what if we do defer? Bam, and there we go. We deferred it, which is great. But instead of just using the defer, we can make it extra readable and say I plus equals 1 and ditch this whole thing altogether. Bam, the same result. And I guess this is again a situation where compiler could optimize it even more. But at this very stage, I will just use for from 0 to 1000, because the 1000 won't be in range, and we just say, hey, this is I. And we actually don't need this anymore. Beautiful. This is use size, whatever, doesn't matter at this point, whatever is better for the processor. And there we go. We got that part. All right. But of course, while loop is not used for just iterating over a number of things. So yeah, that's cool. Very simple syntax. I like it. I really like this thing to just make things clear and not forget about them. All right. And CBN says, the way I understand it is basically struct without field names. A struct, or think of it probably more in the form of an array that just has a specific length, I guess. The only thing that it can probably hold different types, right? Because it can have defined types for stuff. That's how I would expect a tuple. So yeah, maybe struct is a little bit more appropriate in this case. Yeah, sure. Just see what's going on here. Okay, nothing's happening. Good. All right, so let's continue. I think we're gonna finish this chapter today. That'll be fun. So using break and continue. So in Zig, you can explicitly stop the execution of a loop or jump to the next iteration of the loop by using the keywords break and continue, respectively. The while loop presented in the next code example at first sight is an infinite loop, because the logical value inside the parentheses will always be equal to true. But what makes this while loop stop when the I object reaches the count 10 is the break keyword, exactly. So we have some kind of I that we keep increasing, but the while is always true, it never false. But if I is 10, just break, and that's it. No need for any negated checks like in here. Yeah, the moment you see this, you kind of understand, okay, there will be a break keyword somewhere here. All right, or you could probably return from the whole function, right? That's another option. Okay, bam, bam, great. Inside the while loop, we have an if statement that is constantly checking if the I variable is equal to 10. Since we are incrementing the value of I at each iteration of the while loop, the I object will eventually be equal to 10. And when it is, the if statement will execute the break expression. And as a result, the execution of the while loop is stopped. Notice the use of the expect function from the Zig standard library after the while loop. This expect function is an assert type of function. This function checks if the logical test provided is equal to true. If so, the function does nothing. Otherwise, for example, the logical test is equal to false, the function raises an assertion error. Question is, does the assert throw in production? That's a question. Let's try that. So we just do, I mean, here. There we go. Okay, so we've got this part, and instead of standard standard debug, print, whatever. So it looks like testing expect is where it's supposed to be. So we're gonna run it and it should be fine, right? Function cannot return an error. Oh, yep. And something like this, or is it not anymore? What the hell? Okay, everything worked. Okay. Let's say we expected 9. That should throw an error, I guess. Okay, it just throws an error. It doesn't like panic, it just throws an error. Okay. What if I'm gonna do run? Was it like, oh yeah, that was a long time ago. Where did we have the thing that we were trying to do? History restored. Yes, so release fast. There we go. Found it. There we go. Bam. Error. Okay. All right. So still throws errors. The expect works in both production and not production. Cool. And CPN says try standard debug assert instead. Standard debug assert. Oh, and debug will be just standard debug assert. Invokes detectable illegal behavior when OK is false. When debug and release safe in debug and release safe modes, calls to this function are always generated. And the unreachable statement triggers a panic. And release fast and release small modes, calls to this function are optimized away. And in fact, the optimizer is able to use the assertion in its heuristics. Ooh. Yeah, because it says like, oh, this is not supposed to be here. It was tested during the bug. That is all fine. So I'm going to just assume that this value never happens and optimize stuff more. That's cool. Inside a test block, it's best to use the standard testing module rather than this function. Okay. But that's inside the test block, right? This is not the test block. This is just normal code. So yeah, this is fun. So I wonder what is something like Tiger Beetle doing? Are they running fast mode or are they running safe mode? Or is it possible to leave those in the fast build somehow with some kind of flag? Huh. And Nokia says since the standard library is shipped with the computer, you can read the source code of the standard lib just by going to definition. Oh yeah, we can just go to assert and there we go. If not okay, unreachable, and that will probably just make the computer freak out. That's relatively simple, okay? But what makes the... Oh, so maybe it is that the unreachable keyword... Okay, there we go. And debug and release safe mode calls this function are always generated, and the unreachable statement triggers a panic. Okay, so that's what's happening. The unreachable just triggers panic, and everything just falls apart. All right, and in these, it's just not really that, right? Okay, so good. Okay, so we learned a little bit about the unreachable, which I saw before, I think in Primogen's stream, just playing on the side. I was like, oh, there's something unreachable here. Interesting. Alrighty. So let's continue because I might be trying to dive a little bit too deep. Since the code example was executed successfully by the compiler without raising any errors, we know that after the execution, of the while loop, the I object is equal to 10, because if it wasn't equal, the error would have been raised by the expect. Now in the next example, we have a use case for the continue keyword. The if statement is constantly checking if the current index is a multiple of 2. If it is, we jump to the next iteration of the loop. Otherwise, the loop just prints the current index to the console. Okay, there we go. So we could write this whole thing in two ways. Either check if it is, if this is true, then continue. And otherwise, bam. Or you could do, if this is not 0, print. And that's it. Because continue will be automatically assumed. So yeah, one could just change it up a bit. And hey, instead of running it this way, right? Let's just do proper indentation. Bam. Okay, now we're good. So I could run this and it's gonna be like, oh, this thing. Beautiful. But what's up with this thing? I guess that's the end of the program, something? What the hell? But okay, so if this, otherwise we could just say, hey, if it's not equal 0, just print it here and we can save ourselves a line of code. Is it possible to do if statements without the curly brackets, just like a one-liner? Is it possible or is it an error? It's possible. Okay, can I even make it nicely formatted like this? I can. Awesome. Good. Good to know. That wasn't explained. And and Nokian says, I think the book forgot to mention that you can have else blocks on while and for. Ooh, they might mention it later. Well, they won't be mentioning right here. That's interesting. Else statement on. Wait, how would that work? Else blocks on while and for. SPS says you can remove the curly brackets on while loop. Okay, that's cool. How does else work on for loop or on a while loop? That's an interesting one because, nothing suggests that we'll learn that ever. While condition, else this. Oh, as in the moment we break out of the loop, we do something. Wait, what? Oh, it does it like it runs until we actually break it. Else block will with run if the loop is stopped with break. Oh, no, wait. Else block will run if the loop is stopped with break. Okay, I need to test that. So let's do while. Let's just do the I is less than 10. Okay, we're just gonna say, hey, bar I, which is U32, or even more fun, U size is whatever, 0, right? Well, this is this. We're just gonna do I plus plus. Oh, we can do that, right? Plus equals 1. And iteration number. And bam, and this will be the I. Okay. Oops. And let's just move it here. Oops, standard. The debug.print. Okay, so this looks relatively fine. So that will just go on until it finishes, right? So we're gonna do bam. Let's just put a new line. I keep forgetting about that. Bam. Okay, that's good. So what if I'm just gonna throw in else here? Will it just say standard debug? Let's just copy it, it's just too much typing. Else. Will it just magically do something? On this argument. And else. Yeah. Go away. Okay, so it just run at the end. So basically I could say here if I is 5, just break, right? Will it run the else? Oh, this won't run the else. Okay. So basically the while loop is in a way of else will be executed if it naturally found that we reached the end, while the break keyword just breaks the entire thing and just skips. Okay, I see. And NoCam says while condition else, and so, but if you break from it, it won't run. Okay, yep. Okay, this is interesting. I'm thinking of the applications because normally you would break and then would need to do some kind of condition. What was the value and what? So this is kind of interesting situation because it's not that trivial to get this result. At least like the first thing that comes to my mind. Maybe I did something like that and just didn't realize that it was behavior like that. But this is interesting. So this is basically, while loop finished. the natural way. That's what it basically means, right? We run this and it's like, nope. If we're gonna not do this, it'll just finish the natural way. Yep. Okay. All right. So basically, if we were to do something like while true, the else will never, ever, ever run. And Nokia says you can have a cleanup for the case you don't break. Yep. That's awesome. Yeah, one would even, I think this would actually be very useful for throwing errors, because you are expecting that this will eventually get to the situation where, yeah, we found something, and you can go on with your code below with that assumption, but if something turned out to not find it and it actually finished, you're like, oh, I did not expect that. Let's say you gave something 1,000 iterations to try to find a match and then it didn't or something. Yep. Okay. Cool. I see it very helpful. It's surprising that it's not in here. Okay. So what did we do? We did that. We went through this. Okay. There we go. Thank you for pointing that out, by the way. It's awesome to know that the else statement exists. That's super powerful. So function parameters are immutable. We have already discussed a lot of the syntax behind the function declaration in section 112 and 122 and 123. But I want to emphasize a curious fact about function parameters, aka function arguments in Zig. In summary, function parameters are immutable in Zig. So what they try to say here is I expect that all the values passed to it are... Oh, wait a moment. So they're probably saying two things. They're immutable, as we can say, hey, this thing, reassign it to a different value. That's probably one thing. And second thing is that it probably copies the value on call. Therefore, if we throw an array at it, it will copy the array, I'm assuming. So even though we would make the mutations, they won't get outside of the function. So take the code example below, where we declare a simple function that just tries to add some amount to the input integer and returns the result back. If you look closely at the body of this add2 function, you will notice that we try to save the result back to the x function argument. In other words, this function not only uses the value that it received through the function argument x, but also tries to change the value of this function argument by assigning the addition result into x. However, function arguments in Zig are immutable. You cannot change their values, or you cannot assign values to them inside the body's function. This is the reason why the code example below does not compile successfully. If you try to compile this code example, you will get a compile error message about trying to change the value of a immutable, as in constant object. So we have add with our x, and we try to assign x here and then return it. I mean, I personally use this kind of syntax a lot in many cases, because it's like, oh, I already have this variable. It kind of is handy, for example, in JavaScript, where you get some kind of input and maybe you need to trim some stuff, right? Trim maybe spaces from around it, and you just reassign it, and therefore your rest of your code can continue as if this was passed in correctly in the first place. It's kind of too bad you can do that, even though, this is a copy and won't modify anything outside of it. But maybe at the same time, it makes code a little bit more explicit in the fact that you can't modify that, because modification wouldn't do anything. Interesting. And CPN says it copies the argument if copying is faster. You'll get used to this very quick. Yep. I mean, I can see that. I think I worked this. I don't remember what language was it that didn't allow for that either. So no big deal. It's just extra declaration to do something or whatever. No big deal. And it copies when it's faster. Okay. I wonder how difficult it is to know which one is faster. Because copying an array could be slow, could be fast. I mean, it would be considered slow. But I guess if it makes the array completely immutable within that function, then I guess it can do whatever it wants. And for objects on a heap, you refer to them by not value, but by pointers. So at that point, we just pass pointers. So that's another thing. Okay, all right. I guess it becomes intuitive fast enough. Alrighty. So a free optimization. All right. Spin says if the data is smaller than a pointer, it copies it. All right. Otherwise, it probably passes a reference, but pretends that it's not a reference from within this code. Something, I think nim does something very similar. Yep. All right. So a free optimization. If a function argument receives if a function argument receives an input, receives as input. This language sometimes confuses me here. If a function argument receives as input an object whose data type is any of the primitive types that we have listed in section 1.5, this object is always passed by. Well, there we go. We were just talking about that. It always passed by value to the function. In other words, this object is copied into the function stack frame. However, if the input object have a more complex data type, for example, it might be a struct instance or an array or a union value, etc. In cases like that, the Zig compiler will take the liberty of deciding if for you which strategy is best. Thus, the Zig compiler will pass your object to the function either by value or by reference. The compiler will always choose the strategy that is faster for you. This optimization that you get for free is possible only because function arguments are immutable in Zig. I wonder, do we get classes in Zig or something equivalent that you can pass an object that contains like a function that modifies it? What if you call that function? Can you screw this whole thing up? Can you shoot yourself in the foot with that or not? That's a question that will be probably answered when we learn about structs and stuff. And looks like we're gonna do that soon, all right? We'll be able to test that out. All right, so we have that optimization. That's awesome. How to overcome this barrier? There are some situations where you might need to change the value of your function argument directly inside the function's body. This happens more often when we are passing C structs as inputs to Zig functions. In a situation like this, you can overcome this barrier by using a pointer. In other words, instead of passing a value as input to the argument, you can pass a pointer to a value instead. You can change the value that the pointer points to by dereferencing it and whatnot. So I guess here, instead of trying to wrap things in a nice reference or whatever, you just either go pointer or value, and that's it, right? Probably as simple as that. Therefore, if we take our previous add to example, we can change the value of the function argument x inside the function's body by marking the x argument as a pointer to u32 value. For example, asterisk u32 data type instead of a u32 value. By making it a pointer, we can finally alter the value of this function argument directly inside the body of the add2 function. You can see that the code example below compiles successfully, right? We just expect to have a pointer to a u32, and we don't need to return anything because we just do the worst, I guess at in place or whatever. Constant d, right, is this, and x dot asterisk is, so set the value, get the value, whatever the reference, plus this. Okay. All right. This is interesting. I hope we're going to learn about pointers somewhere here. A little bit more. There we go. Pointers and optionals. And in our main, we just need to pass it. So I guess ampersand for getting a reference to x. Okay. All right. Even in this code example above, the x argument is still immutable. Which means that the pointer itself is immutable. Therefore, you cannot change the memory address that points to. However, you can dereference the pointer to access the value that points to, and also change the value if you need to. So I guess if you also want to change the pointer, we need to basically send a pointer to a pointer. And can we do that? Is it as simple as in the other places? Oh, look at that. They actually use the modern syntax here for the first time in the book. What? I guess they would need some pull requests to fix up the other examples. And Spian says there's no class, but structs can get you very close. All right. We'll see that within probably half an hour or something. Alrighty, so we have this. What if we want to do something like swap function swap to whatever? We're gonna have a, which will be not just pointer. Let's just start with that. Pointer u32, b pointer u32. Okay. Whatever, increment and swap. There we go. Something weird. And we return void. Alrighty. And what we're gonna do here is basically say, not colons. This is wrong. There we go. So let's say that what I would normally do is, because we can increment it, right? So a, this is extract the value and +1, right? And the same thing goes with b, where we just do this. So at this point, we incremented them. And now I would need to basically say that, hey, a is this. So I guess I would need to have that, hey, var temp is, I mean, here I can just do probably constant temp is just extract the value from b. All right, so we don't lose it. No, from a, okay. There we go. So a is this, and then b dot this is temp, right? So we have this situation. I know that I could, in theory, just do calculation here, no big deal. But in this way, we swap the values of those. But what if I don't want to swap the values for some reason? I want to swap the pointers. Can I make a pointer of a pointer? Here and here? If I want to do that, I do this. Right? I mean, that's what logic would say. Okay, I increase the both, and now temp will be pointer to A, and then A will be a pointer to B, while B will be the pointer to A. That's it. I think that's how it should work. And so we increase both values, and then we swap the pointers. Okay. And CPN is not appreciating my pointers to pointers. Yeah. So let's do this. So basically we have X, which is number 4. We have for Y, which is another one, whatever this, right? And we do not just to the value, can we do double ampersand, or we need to do shenanigans with parentheses? Okay. All right. Not add. We need to use our increment and swap Bam. So now we could, in theory, do stuff. So let's say that I'm gonna skip the increment part, right? We're just gonna literally swap them because we don't want to confuse stuff. So in this case, I should swap them. So I can basically say print x is this and y is this. So we just send x and y. So normally it'll be 4 and something. Now it'll be something and something. Yeah, I guess. Let's see if it works. No. Expected type this, found constant this. Oh. Oops. And Nokia already says types will match, won't work. Okay, so I'm probably missing some point here. Do I need to define it as a variable pointer to be able to swap pointers? And therefore, how the hell would I assign a value now? Like this? Wow, that looks so weird. And Nokia says since ampersand x generates a temporary value, so it's a constant, you would need to assign to a variable. Ampersand x. So we don't have ampersand x here. We have it here. So this... Oh, that's right. So I don't need to do this crazy stuff. I would just need to say, hey, var px is this, and var py is whatever, y. Okay, it shows that these are modifiable pointers at this point. Therefore, I can just do pointer to px, and this will be pointer to py. And now it should magically work, possibly. Yes! Okay, x became 4. No, x is still 4 and y is still that. Oops. Oh, because... Oh, right. So I will basically need to say, hey, we're doing this. And we're doing this here. Okay. Sure. I don't like that, but okay. Makes sense. And this, of course, cannot dereference non-pointer type U32. Yeah. Px, py. Naming, but now they swapped. Okay. I guess the moment you start dealing with structs and objects, you kind of don't get to this weird situation. So it kind of makes sense because you're already defining them as pointers because you have them somewhere and whatnot, instead of doing this weird by value stuff. But yeah, okay, that makes sense. That was already a fun exercise ahead of pointers chapter. And CPS says you shouldn't be able to do this with stack memory. Yep. Okay. Alrighty. This works. Okay. At the same time, if this is a pointer to x, so we assigned the pointer to x. Oh yeah, because this was a pointer to x. But no, we swapped the pointers. We literally swapped the pointers. So why wouldn't it change? Oh, because we didn't change those, right? We just swapped whatever this holds. Yep, that's what it is. Yeah. Okay, makes sense. Yep, that was the whole idea of that. If we just wanted to swap the value, we could just do it the other way around. Yep, makes sense. CPN is, can you go back a little? Yeah, this is fun. Oh, what do we mean go back? By undos? That'll be plenty of undos. And we had this thing, right? Bam, 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 bam. And this was unhappy. Yeah, because this was pointing to constant or something. Generates a temporary value, which is a const. Okay, so basically it will be a temporary value. That's why. All right. Try at const cast. How do I use it? Where do I use it? It's kind of vague. But something tells me we're entering the territory of trying to really force it to work. Something that I'm a little bit beyond. So I'm going to wait for an answer and read in the meantime. All right. So we went through this thing with those pointers, right? Even if the code example is still immutable, that's why we need to, the pointer itself is immutable, and therefore we were able to do stuff. All right. So structs and OOP. And CPN says try add const cast. Const cast. Remove const qualifier from a pointer. I think that would need to be this then. Something like that, I would say. All right. I mean, we can see var ABC is this if we're gonna get any hint, but nope, we won't. And this will probably print wrong files, but we'll compile. Again, nope. Expected this, found, oh, still didn't work. Didn't work, but we can try the other variant, of course, of just doing this and see what happens, but I don't think it's gonna work. Wait a moment. What's going on here? This, open, close. Oh, I have double one here. There we go. Oh, this worked to some extent. I mean, it didn't swap anything. So I don't know what it did, but it compiled. It's like it just swapped them behind the scenes. The value themselves won't be swapped. It just, whatever the swap happened was somewhere behind the scenes to the pointer that we lost by the time we exited from this. Yeah, all right. I won't delve into that. It's a bit too forward, but it's interesting. So yeah, Nocam says swap the temp values, but you are not using it though. Exactly. So it kind of shortened what we were doing there. So it's interesting to know that there is something like that. Interesting. We'll see how it works in practice. But again, I don't have enough knowledge yet. Okay, but looks like after this chapter, with all the structs and whatnot, we'll start entering memory and allocators. So our next stream will be actually dealing with heap. Alrighty, so structs and OOP. Like, I did not expect to see OOP suddenly in a second chapter. So Zig is a language more closely related to C, which is a procedural language that it is to C++ or Java, which are object-oriented languages. Because of that, you do not have advanced object-oriented programming patterns available in Zig, such as classes, interfaces, or class inheritance. Nonetheless, OOP in Zig is still possible by using struct definitions. With struct definitions, you can create or define a new data type in Zig. These struct definitions work the same way as they work in C. You give a name to the new struct or to this new data type you are creating. Then you list the data members of this new struct. You can also register functions inside the struct, and they become the methods of this particular struct or data type. So that every object that you create with this new type will always have these methods available and associated with them. Awesome. In C++, when we create a new class, we normally have a constructor method or a constructor function, which is used to construct or instantiate every object of this particular class. And we also have a destructor method or a destructor function, which is the function responsible for destroying every object of this class. In Zig, we normally declare the constructor and destructor methods of our structs by declaring an init and the init method inside a struct. All right. This is just a naming convention that you will find across the entire Zig standard library. So in Zig, the init method of a struct is normally the constructor method of the class represented by the struct, while the dinit method is used for destroying an existing instance. Alrighty, simple. No weird syntax, just methods. So the init and the init methods are both used extensively in Zig code, and you will see both of them being used when we talk about allocators in section 3.3. But as another example, let's build a simple user struct to represent a user of some sort of system. Okay. If you look at the user struct below, you can see the struct keyword. Notice the data members of the struct: ID, name, and email. Okay, let's just take a peek. So we have the standard stuff. Const user is struct, and we have ID of this, name of just a slice, like string slice, and email also a string slice. And okay, so we read that. Every data member has its type explicitly annotated with the colon character syntax that we described earlier in section 1.2.2. But also notice that every line in the struct body that describes a data member ends with a comma character. So every time you declare a data member in your Zig code, always end the line with comma character instead of ending it with the traditional semicolon character. Okay, that's a good thing to point out. It's just a list, right? So you could do it in one line in theory. Okay. Next we have registered an init function. And by the way, CPN says, I gotta dig deeper on my own. Be right back. Happy digging. All right, next we have registered an init function as a method of this user struct. This init method is the constructor method that we will use to instantiate every new user object. That is why init function returns a new user object as a result. So let's see. So we have function, so it doesn't have any special syntax. The only special thing about it is it has a name init. So it's a convention, it's not a restriction, I guess. I wonder if the compiler will also scream at you if you don't have init and dinit defined. But it looks like we don't have the dinit, so maybe not. Let's see. So init, excuse me. So init is ID u64, name is constant u8, and email and that. So these are our standard entries. I can already see that we have exactly the same names, okay? And returns user. And in our body, we are returning user, and we just created like this. I guess .id, that refers to this, the ID of this, and name of this, and email of this. So this is similar to like we had in enums. And we just assign those values. Alrighty. So I wonder if outside of the struct we can also call this. Something tells me. And then we have print name, self, user. Okay, so we have the self context. Okay, that looks familiar. All right. Yeah. And Nokiam says init and the init are just conventions. Okay, thank you for clearing that out. Alrighty, so here we have the print name with a self user. So that means we can omit that and we'll just automatically say like, hey, whatever. Try standard print. I need to run this piece of code because I already want to experiment with that without even reading the whole thing. Can I like move the terminal to a side or something? Just takes up so much room. And this takes up so much room, top too. Oh, so annoying. F11. And that's only this, so nope. Never mind. Okay, so we've got this thing, return user, whatnot. I know what I can do. Let's just, yeah, let's just do this. Larger. We are in temp Zig, Ziglings exercises. There we go. So we can do, what was it? Zig run name? Yeah, Zig run. This. There we go. Okay, so that works. Beautiful. So we can close this and focus on coding. There we go. So we put this in, it reformatted it for us. All right, so we have our init and we have our print name, all worked. We gave it Pedro, an email, and print name will just print email. I mean, just the name. So that's simple enough. But now the question is, can I do something like this? After try your print name, wait, standard out. This is gonna crash, right? Yeah, of course. You go away. No tries. Just do it. Don't try. Just do it. Standard debug print. And that means we're not throwing error. Therefore, we don't need a try here. And code is simpler. Beautiful. And now it runs. It says Pedro. So what if I wonder, can I do user dot print name? And now I'm specifying that it's the U. Will that work? Yes, it works. That means that all the functions can act as, so they're basically defined as equivalent of a static function in some other languages. That's why we have to have, that's why we absolutely have to have the self. All right. So I think some other, Lua didn't do something similar. Probably some other languages. All right, cool. So we can do that. Another thing is, do we really need that init? I know it's a convention. We can just do user init, which is fun. But can I just throw this in here? Like, why bother, right? So constant B is this. So instead of return, it will be just user and ID will be 2. Name will be Ben. And email will be, oops, not here. Let's just do it here. Come on. Xconti and xconti.tech. Alrighty, we've got this. And B is unhappy. I need to use local constant because we need to print here. Will this work? Yes, it does. Okay, so basically init is nice because we don't have to type in ID or whatnot or whatever. But in theory, you don't have to have it. So it's not like I'm gonna remove this and suddenly the whole thing falls apart. You don't have to have it defined, right? Yes, we don't have to have it. Okay. And Nokia says, yep, instance method is just syntax sugar for function instance. Awesome. I like this kind of, I like how easy it is to look what's happening behind the scenes. All right. So we know that and it's a nice convention and that's pretty much it. All right. So the pub keyword. All right, do we have any? Yes, we have pub here and nowhere else. So the pub keyword plays an important role. Oh, so we're just gonna go straight to some other stuff. Okay. Pub keyword plays an important role in struct declarations and OOP and Zig. In essence, this keyword is short for public, and it makes an item or component available outside of the module where this item component is declared. In other words, if I don't apply the pub keyword on something, it means that this something is available to be called or used only from within a module where this something is declared. All right, so now the question, what is a module really? To demonstrate the effect of this keyword, let's focus again on the user struct that we have declared on the previous section. For our example here, let's suppose that this user struct is declared inside a Zig module named user.zig. If I don't use the pub keyword on the user struct, it means that I can create any user object and call its methods, print name and init only from within the module where the user struct is declared, which in this case is the user Zig module. This is why the previous code example works fine, because we declare and also use the user struct inside the same module. But problems start to arise when we try to import and call or use this struct from another module. For example, if I create a new module called register.zig and import the user.zig module into it and try to annotate any variable with the user type, I get an error from the compiler. It's just, hey, the user is not marked pub. Oh, not like the user is not defined or not available. It just tells you it's not marked pub. So I like it, just gets straight to the point. Suggests, hey, maybe you modify it. Therefore, if you want to use something outside of the module where this something is declared, you have to mark it with the pub keyword. This something can be a module, a struct, a function, an object, etc. And Nokia goes ahead and says a Zig module is defined by the build system. The language per se has no concept of module, just files, I think. Here, when he says module, just think of file. Yep. Okay. I looked at some build stuff, and yeah, it would look like modules and whatnot. Alrighty. For our example here, if we go back to the user Zig module and add the pub keyword to the user struct declaration, then I can successfully compile the register.zig module. Okay, so we can throw in pub in front of const and it will just work. Okay. Can you make pub var user struct? I don't think so. But that'll be fun. All right. And then we have register Zig and we can just import it and suddenly, yay, it works. Now what do you think will happen if I try to call from register Zig any of the methods of the user struct? For example, if I try to call the init method, the answer is I get similar error message warning me about the init method is not marked as pub, as you can see below. Okay, but I guess the fields don't have to be defined like that. Thus, just because we have applied the pub keyword to the struct declaration, this does not make the methods of that struct public as well. If we want to use any method from a struct, such as init method outside of the module where this struct is declared, we have to mark this method with the pub keyword as well. Going back to the user Zig module and marking both the init and print name methods with the pub keyword makes them both available to the outside world, and as consequence makes the previous code example work. Right? Bam, pub init. And the same thing here. It all works. Beautiful. And Nokia says also all files are implicitly a struct, so you can just add fields to the global scope of a file. You can try to see. Okay, so you can add fields to the global scope of a file. So in this case, you're saying that, instead of having stuff in main, I could just throw in, what we're gonna do. Var. Wait, Here they were defined. Wait, here they are defined as just that. So can I just do magically? What on earth would I say? Bread, boolean, comma? It doesn't complain about the comma, it complains about this, so this is extra confusing. But will it run? Yes, it runs. Wow, isn't that confusing? So I guess this entire, excuse me, so this whole thing I guess would be considered to be a module. And bread is suddenly exported, isn't public now, or do I do pub? Nope. Huh. And CPN says Zig modules are just structs. And Nokim says, for example, if you have a file called user.zig and you put the fields of user there, you can import and instantiate them. Okay. CPN says you found the secret. So this is interesting. I guess when we learn a little bit more about modules, or when I learn a little bit more about actual modules, it will start clicking and how to use them, because right now this is kind of a little bit abstract how to use it from the outside. Because there's no way I can define the whole thing as public, right? I guess through the build system I would be able to define if this file is public or whatnot. But on something like user, I can say, hey, this is actually public. And I can probably do that. This module, right? Test.zig, right? .user, capital U, and I'm getting this specific constant from there. So that makes sense. I do pub here and can do stuff. But with this, I cannot define pub, so unless just importing it already makes it public. Who the hell knows? All right. That's because we have applied the pub. This does not make the methods public as well. Yeah, we basically need to pub in front of everything. Okay, that makes sense. And Okim says the field are always public, only the declarations you can specify the visibility. All right. All right. Okay. Forgot to grab water. Huh. Anonymous struct literals. You can declare a struct object as a literal value. When we do that, we normally specify the data type of the struct literal by writing its data type just before opening curly brace. Okay, for example, I could write a struct literal value of the type user that we have defined in the previous section like this. Bam. We tried that already, so that's cool. However, in Zig, we can also write an anonymous struct literal. Okay, that is, you can write a struct literal but not specify explicitly the type of this particular struct. An anonymous struct is written by using the syntax .bam. Okay, so it's not a tuple, it's actually a struct. So we can we essentially replace the explicit type of a struct literal with dot character. All right. As we described in section 2.4, when you put a dot before a struct literal, the type of this struct literal is automatically inferred. As we described in a section 2.4, as we will describe, that's in the next section. What the hell? The type of the struct literal is automatically inferred by the Zig compiler. In essence, the Zig compiler will look for some hint of what is the type of a struct. This hint can be the type annotation of a function argument, or the return type annotation of the function that you are using, or the type annotation of an existing object. If the compiler does find such annotation, it will use this type in your literal struct. And CPN is also known as a tuple. Okay, so interesting. So basically tuples have named fields. All right. Okay, I can live with that. Every language does its own take on it. Anonymous structs are very commonly used as inputs to function arguments in Zig. One example that you have seen already, if you have seen already constantly, is the print function from the standard out object. This function takes two arguments. The first argument is a template string, which should contain string format specifiers in it, which tells how the values provided in the second argument should be printed into the message. Oh, but we were able to not actually specify the names in there. So it's more of a tuple with unnamed stuff, unnamed fields, whatever. Well, the second argument is a struct literal that lists the values to be printed into the template message specified in the first argument. You normally want to use an anonymous struct literal here, so that the Zig compiler does the job of specifying the type of this particular anonymous struct for you, right? So we do this and we just create an anonymous struct with one field, which is who knows how it's named, but it contains a string, I guess, I don't know, will it automatically default to a slice? Probably not, just to a string array or whatever. Okay. And I guess that's all we get about it. Wow, okay, that's just a little bit disappointing. Struct declarations must be constant. Types in Zig must be const or comp time. And like it says, it's named .at and the string 0. I am not kidding. Okay. Try reading the implementation of the print function. Sure, let's look at the print function. Maybe we'll actually survive it. Right? So we have comp time format. Okay. And then we have arguments any type. And then we create a buffer, bit writer or whatever. We get some kind of standard error writer. We defer unlock for it, and then we do no suspend. I guess so. Oh, this might be so that doesn't get interrupted or something. Print, and we have a little smaller print that takes the same arguments. In this case, again, any type. All right. Arguments type of arguments. So get the type of arguments, and arguments type info. Type info from this. So we have lowercase type and capital type. That's funny. If argument type's info is .at struct. Okay, so .at and this thing, it sounds like some kind of what is it, symbol? Like equivalent to a symbol or something in like JavaScript or something. Compile error expected tuple or struct argument found this. And we can actually print it. This is fun. Okay. And then we go arguments type. So fields info. We take the argument type dot this. I guess that's how we, okay, this is getting weird. So I guess this is reflection system. That's compile time or something, I guess. And then we get fields out of that and we can start iterating over them. Bam, 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 bam. And then inline while, and we'll be iterating over them. Okay, I'm not gonna read more because this is getting more and more cryptic. The .at is just to escape keywords. Okay. By the way, at is used to give any name to a variable, function name, etc. So since struct is a keyword. Okay, all right, so we're escaping that. And in the other case was dot at 0 because we're escaping the 0 as a numerical literal. Okay. All right. Interesting. Maybe one day this book will get to it, although I'm not sure because it already seems to be skipping a lot of stuff, which is unfortunate. Or maybe they just keep expanding it. Who knows? Okay, so types in Zig must be constant or comp time. Okay, so that's for types. We're going to talk more about comp time in section 12.1. What this means is that you cannot create a new data type and mark it as a variable within with a var keyword. So struct declarations are always constant. You cannot declare. I'm so sorry. I don't know why I'm yawning so much today. You cannot declare a new struct type using the var keyword. It must be const. In the vec3 example below, this declaration is allowed because I'm using the const keyword to declare this new data type, right? But this will be still, during the compilation, it will kind of make it work. It's not something that can be constructed during the runtime. And okay, that's it. Okay. Great. CBN says constant at a space b of this type is 0. Yep, it's a valid syntax. Yep, we're just escaping stuff. Makes sense. Let me just try that something. Can I make let's say instead of a constant b, I want constant, and we do at the constant. Okay, it looks like we can do that. Sure. You can escape the quotes within that. All right. Okay. Makes me weirdly happy. Still don't know what's the point of that, but maybe when dealing with JSON and other dynamic data, it could be handy. Works. Oh yeah, and emojis and everything. Basically anything Unicode will work, right? How do I add emojis here? Lightning. There we go. It's weird on Linux at points. Bam. Yep, and that will work. Bam. Yep. Alrighty. So let's go to the more OOP stuff, right? In every language that has OOP, when we declare a method of some class or struct, we usually declare this method as a function that has a self argument. This self argument is the reference to the object itself from which the method is being called from. It's not mandatory to use self-argument, but why would you not use this self-argument? There's no reason not to use it, because the only way to get access to the data stored in the data members of your struct is to access them through this self-argument. The only way to get access to data stored in the data members of your struct is to access them through the self-argument. I mean, if from within the function you're defining on it. Yeah, of course. If you don't need to use the data in the data members of your struct inside your method, you very likely don't need a method. I mean, you can still define it as a static method, so you could do it just to group stuff. You can just declare this logic as a simple function outside of your struct declaration. No, that's where that's not nice. Take the vector3 struct below. Inside this vector3 struct, we declare a method named distance. This method calculates the distance between two vector3 objects by following the distance formula in a Euclidean space. Notice that this distance method takes two vector3 objects as input, self and other. Yep, so we import math. Look at that. We have from std, we just take math, right? And say it's m. We declare a struct that has a public function distance, and it takes self, so whatever we call it on, and the other one. So we basically do power to this and whatever, power to that, and then we'll take a square root of everything, add it up. Okay, makes sense. The self argument corresponds to the vector3 object from which this distance method is being called from, while the other is a separate vector3 object that is given as input to this method. And the example below, the self argument corresponds to the object v1 because the distance method is being called from the v1 object, while the other argument corresponds to the object v2. Oof. I'm kind of reading fast because this is like really obvious. Yeah, distance is v1, distance to v2. Great. About the struct state. And Nokia says C interop mostly. Okay. Yeah, it's not the only way. You can just pass an argument explicitly. Yeah, of course, you could pass as an argument explicitly. Yeah, I could do, instead of having this, right? Well, we need math. I could simply do, you know what? We're gonna do that the distance is not between A, which is vector, and B, right? So everything will have this will be A, everything here will be B, and this will work as well, but that means that we'll need to do, you know, vector, create them somewhere here so that we can kind of copy them, right? So we have those two vectors defined. And what we can do now, we have to do vector3 dot distance, and now A will be v1 and B will be v2. So you have something that looks a little bit more how you would use, I don't know, in Go, I guess, or many other programming languages that don't like to give you to define stuff on top of stuff. Yep. And it would be just nicer to do v1 dot distance to v2. It just flows better, and you can do dot and do stuff on the result. Yeah. And v1 distance v2 will still work here, really. So it truly doesn't care about the stuff. So I guess we need to do this, and we need to do this to just make it not complain. Okay, it worked. All right. So we just don't need to use self. It's another convention. So they're lying to us in the book again. Or like skipping the facts, I guess. I appreciate somebody writing a book and making it open source like that, but at the same time, come on. I don't know, it's just like brushed off, like, we're gonna skip some stuff. Or maybe it's just because the novel goes more in depth, but it isn't suggested. Usually in a book, you want to go full depth from the beginning. Or like have an overview and then actual full depth. So, yeah. Spia says, also you can attach methods to data and Go too. Okay, yeah, I guess there was something like that. I just haven't done much. Yeah, although I might be doing some stuff in Go in the future because I'm in what is it called? In a process of you know, interviewing with a company that does Go as a backend. So I would need to skill up fast. Alrighty. Let's continue. Because this is kind of expanding. I don't know how much I can talk more today. So we have another subchapter about the struct state. Sometimes you don't need to care about the state of your struct object. Sometimes you just need to instantiate and use the objects without altering their state. You can notice that when you have methods inside your struct declaration that might use the values that are present in the data members, but they do not alter the values in these data members of the struct in any way. The vector3 struct that was presented in section 234 is an example of that. This struct has a single method named distance, and this method does use the values present in all three data members of the struct, x, y, and z, but at the same time, this method does not change the values of these data members. Yep, they're read-only. As a result of that, we create vector3 objects. We usually create them as constant objects, like v1, v2 objects presented in section 2, 3, 4. Okay, so when we create them as constant, that means that also their fields are being considered constant. Oh, okay. We can create them as variable objects with the var keyword if we want to, but because the methods of the vector3 struct do not change the state of the object in any point, it's unnecessary to mark them as variable objects. But why? Why am I talking about this here? This is because the self argument and the methods are affected depending on whether the methods present in the struct change or don't change the state of the object itself. More specifically, when you have a method in a struct that changes the state of the object, for example, changes the value of the data member, the self argument in this method must be annotated in a different manner. There we go. So we're getting into the fun part. As I described in section 234, the self-argument in methods of a struct is the argument that receives as input the object from which the method was called from. We usually annotate this argument in the methods by writing self followed by the colon character and the data type of the struct to which the method belongs to. Okay, if we take the vector3 struct that we defined in the previous section, we can see that this is a method that the self-argument is annotated because the state of vector3 has never altered this method. Great. But what if we don't have a method? What if we do have a method that alters the cost? It just goes in circles and repeats the same thing. But what if we do have a method that alters the state of the object by altering the values of its data members? How should we annotate self instance? The answer is we should annotate self as a pointer of x instead of just x. Okay, so this is... Okay, all right. In other words, you should annotate self as a pointer of x instead of annotating it as self of x. Okay, so by default, they are immutable. All right. And because it's just an argument, that already means it's a constant. Okay, that makes sense. If we create a new method inside the vector3 object that, for example, expands the vector by multiplying its coordinates by a factor of 2, then we need to follow this rule specified in the previous paragraph. The code example below demonstrates this idea, right? So we have this standard way, and the distance is this, while twice we'll just modify the thing, right? So we say self is pointer to vector3, and I guess it automatically structures it. We don't need to do dot star dot x, which is the dot x, and just like I believe C++ or something, it automatically destructures it. Okay, makes sense. And CPN says, why is the convention self and not this, even though Zig calls it add this? I mean, I don't know. Different languages. Some languages use self, some languages use this. And I think, in my opinion, whenever you have a language that requires you to define the first argument manually, you usually will use the convention self instead of using this in here. Whenever you have this, it's usually a reserved key. That's what I noticed so far. So they might be just going with a convention of every other language so that they kind of fit in and that they don't confuse you even more. I guess. So an example of something like this with those vectors would be, I did something similar, actually in Go, github.com/xconti. Whoa, that's large. GoVec. There you go. How long ago was it? I fixed some stuff here, but other than that, I think I worked in it like 2 years ago. For example, if we will go to minimum, max. Yeah, I guess minimum, right? So here we have an example where we have a minimum function that takes like vector2 of x and y and just returns a new one. But you also have a minimum in place, so it still takes itself and whatever, an extra one, but it just replaces the one in place. So we could do something of this sort, right? As an example, I guess this is what it's defined on as a v, and this is the other. So let's try to do something like that for this vector3 in here. So we have the vector3. Let's get rid of the user and the red and whatnot. It's not a concern anymore. The same thing with distance, but we'll use those two. So let's say that I'm gonna paste these. So the idea is that we have a public function that, that basically is called minimum. And here we have from lowercase, which will take basically self vector3 and other as vector3. All right. And it will return a new vector3. There we go. So we basically will do bam. Return this thing, which will be x will be basically self.x plus other.x. Let's do it nice way, nicely formatted. So be pretty much the same thing, and z will be pretty much the same thing. Only thing, we have y here, and we have z in here, and that's it, right? So that's the equivalent of the normal one that creates a new element, right? Returns a vector with a minimum of each component of the two vectors, right? While the other one, the minimum in place, we can just copy this one so that we do it, but it will be basically in place. Like this, right? Oh, please copy this. Bam, bam, bam. And this needs to be all lowercase because it's different, whatever. Updates the vector in place. So we would need to basically have a pointer to vector3, right? And we don't need a pointer to vector3 because it just doesn't have to be. It's not gonna be modified. So instead of returning that, we can just say simply self.x is this. Bam. And self.y is this. So let's just do self, 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 and bam, bam. And there we go. And we should be able to use it, right? So let's say constant v3 will be the new one, right? The one that will create it. So it will be v1 dot minimum, and we do v2, right? or I could do v1, right? Minimum of the two, but it doesn't matter. Okay. And then we have constant v4. No, we actually don't do that. We just do v1. We're going to modify it, minimum in place. And that will magically use it as a variable. And the other one will be v2, right? So that means I will need to define this one as a variable. And there we go. And then whatever, this is v3. I guess this will work. No, it won't work. Function with non-void return type. Oh, right. Void. Yes, it worked. Okay, cool. So before reading stuff, I just learned that, okay, basically Zig will pass this as a pointer automatically. Okay, all right. And CPN says, by the way, there's a built-in minim function. Okay, great. I was just making an example of something that I did here. This one has tons more, I know, rotate by degrees, right? You take vectors and you can rotate by stuff. Did a bunch of that because there was no decent one that I enjoyed to go for some reason. But yeah. Okay. So we did all that, and they showed us that, hey, you can do twice, and notice in the code example above that we have added a new method to our vector3 named twice. This method doubles the coordinate values of our vector object. In this case of the twice method, we annotated the self argument as vector3, indicating that this argument receives a pointer or a reference, if you prefer to call it this way, to a vector3 object as input. We can just call it twice, and as long as this is a var, it'll work. So it's okay, very similar to how you have in probably some other languages like nim, for example. It's just in nim, you wouldn't use this, you would use a reference or something. All right. CPN says, be right back. Alrighty. So let's see how far we get from here. Now, if you change self argument to twice method to BAM, like the distance method, you will get to self vector3. Like, yeah, you'll get compiler error because you can modify it. Yep. Notice that this error message is showing a line from the twice method body, indicating that you cannot alter a value of X data member. Right? I cannot assign a to constant. BAM. And it's upset about the self because the self itself is constant. This error message indicates that the X data member belongs to a constant object, and because of that, it cannot be changed. Ultimately, this error message is telling us that the self argument is constant. Because it's just a normal function, it works just like before. There's nothing special about it. Okay. If you take some time and think hard about this error message, you will understand it. You already have tools to understand why we are getting this error message. We have talked about this already in section 2.2, so remember, every function argument is immutable in Zig, and self is no exception to this rule. In this example, we marked the v3 object as a variable object, but this does not matter because it is not about input object, it's about the function argument. Mark the v3 object as a variable object, but this does not matter because it's not about the input object, it's about the function argument. Wait a moment, what? The v3 object as a variable. Where's v3? Is this. We did twice. I think if we would make it, so something like this here, right? If I would make it constant, I don't think I'll be able to modify it, right? Exactly. It's unhappy, numbers declared here. Expected type, bam, found constant, pointed to a constant, exactly. So that's the problem here. It needs to be var. So what the hell are they talking about here? In this example, we mark the v3 object as a variable object, but this does not matter because it's not about the input object, it's about the function argument. Yeah, but for it to be able to change stuff in the pointer, you still need to make it variable. The problem begins when we try to alter the value of self directly, which is a function argument, and every function argument is immutable. Okay, so repeat. Great. If a method of your extract alters the state of the object by changing the value of any data member, then remember to use the pointer instead of not pointer. Isn't this the point of this entire thing? Why is it repeated yet again? And yet again. What the heck? Let's move on to type inference. Malcolm says he is saying that in this case the error is because of the functions. Yeah, it's just but they said it in a way as if the other thing was a problem. But yeah, I understand. Alrighty. So type inference. How many? Okay, this is not okay. We're towards the end. All right, good. We'll be able to finish without me losing my voice because I think in the morning I have another live stream. Oh dear. Zig is a strongly typed language. But there are some situations where you don't have to explicitly write the type of every single object in your source code, as you would expect from a traditional strongly typed language such as C and C++. Hey, in C++ you have auto keyword and you don't have to some extent. You still need to have to type auto everywhere. In some situations, the Zig compiler can use type inference to solve the data types for you, easing some of the burden that you carry as a developer. The most common way this happens is through function arguments that receive struct objects as input. CPN says, drink water. I don't have water around me. We'll need to go upstairs, find a glass, pour water, just too much work. It's not too bad. So the most common way this happens is through function arguments that receive struct objects as input. In general, type inference in Zig is done by using the dot character. Every time you see a dot character written before a struct literal or before an enum value or something like that, you know that this dot character is playing a special part in this place. More specifically, it's telling the Zig compiler something along the lines of, hey, you can infer the type of this value. Hey, can you infer the type of this value for me, please? In other words, this dot character is playing a similar role to the auto keyword in C++. There we go. I gave you some examples of this in section 234, right? With the anonymous struct literals. Okay. Where we used anonymous struct literals. Anonymous struct literals are struct literals that use type inference to infer the exact type of this particular struct literal. Oof. And Nokim says this is not actually type inference. It's more like coercion. Okay. This type inference is done by looking for some minimal hint of the correct data type to be used. You could say that the Zig compiler looks for a neighboring type annotation that might tell it what the correct type would be. Another common place where we use type inference in Zig is at switch statements, which we talked about in section whatever. I also gave some other examples of type inference in section 212, where we were inferring the data types of enum values listed inside a switch statement. Again, we have that dot. But as another example, take a look at this fence function reproduced below, which comes from atomic.zig module of the Zig standard library. Okay, there are a lot of things in this function that we have. Where is fence? All the way down here. Okay. There are a lot of things in this function that we haven't talked about yet, such as what comp time means, inline, extern. Let's just ignore all of these things and focus solely on the switch statement that is inside of this function. So let's take a peek. So we have function as inline fence. It can modify the self object because it's a pointer to capital self. Okay, great. This suggests maybe generics or something. Then we have comp time, order, atomic order. All right. Void. So we have a bunch of stuff here, if this and that. And if our switch statement on order, where's order coming from? It's an atomic order. Okay. So dot unordered, dot monotonic, do this. And we have compile error, name tag, order, whatever. Acquired, do this. Release, do that. And okay, what is the type inference here? Okay, so we can see that this switch statement uses the order object as input. This order object is one of the inputs of the fence function. And we can see in the type annotation that this object is of type atomic order. We can also see a bunch of values inside the switch statement that begin with a dot character, such as .release, .acquire. Because these weird values contain a dot character before them, we are asking the Zig compiler to infer the types of these values inside the switch statement. Then the Zig compiler is looking into the current context where these values are being used and trying to infer the types of these values. Oh, what the heck? This is confusing. Okay, so it's looking for acquired. So basically looking where it's coming from, that it's coming from the order. That's what it means. All right. CPN says it's a conversation. Wait, it's a conversation that the const self is at this within a struct and use self instead of the name of the struct everywhere. Okay, so just a convention, huh? Const self is this. Okay, all right. Order in this, and Nocam says order in this case is just an enum, and dot acquire is just an enum value. Yeah, it's an enum value. So basically, because it's a value, what it wants here is not a value. What it wants is a type to be able to filter through those type of that value. Still kind of doesn't make any sense. It's just weird. I don't know. Because type of the value is the type of the order. And we want to do by the value of the order, not by the type of it. I don't know. This is weird. Since they are being used inside a switch statement, the Zig compiler looks into the type of the input object given to the switch statement, which is the order object in this case. Because this object has type atomic order, the Zig compiler infers that these values are data members from this atomic order. I mean, I don't think it infers it from here. It infers it from here. So the moment we shove order in here, it already knows that it's of this type. So I don't understand why it is explained that it's coming from here to back here. What the heck? Nakan says, yeah, that is why I said it's not actually type inference. Yeah, this is a little bit misleading. Yeah, this is a very strange explanation. Let's move on because kind of type inference makes sense. I just don't understand those dots so far. Yeah, I guess the dot with the thing, but it just sounds like the dot itself doesn't do anything. What doesn't, it just makes it a little bit more of a that the syntax requires the dot to be there, but the dot is commonly used in the situations where type things are somewhat smart, and that's it. I don't know. Just a theory. Nokin says it's not inferring anything. The compiler knows the type of order. Yeah, as of type atomic order. Exactly. Const user is user dot thing. Okay, and basically the dot will make it, hey, just figure out what to place here, right? And because we specify user somewhere else, it just does that. Okay. Don't know why you would need to put a thing in there, but okay. Strange. Okay, so this is how basic type inference is done in Zig. If we didn't use the dot character before the values inside the switch statement, then we would be forced to explicitly write the data types of these values. For example, instead of writing .release, we would have to write atomic.release. I think that dot is just purely to signify that this is a part of the thing, right? And not to infer it or anything. I mean, it infers whatever. Just without the dot, if we had just release, it could refer to a variable called release. This way, we just don't have a collision, and that's all it is, in my opinion. We would have to do this for every single value in a switch statement, and this is a lot of work. That's why type inference is commonly used on switch statements in Zig. Great. Disregard this whole section. It's effed up. Typecasting. In this section, I want to discuss typecasting or type conversion with you. We use the typecasting when we have an object of type X and we want to convert it to an object of type Y. For example, we want to change the data type of the object. Most languages have a formal way to perform typecasting. In Rust, for example, we normally use the keyword as, and in C, we normally use the typecasting syntax. For example, this, right? We want an int, and there it is. In Zig, we use the @as built-in function to cast an object of type X. So I'm noticing that there is a set of functions starting with @, like those built-in functions. I guess that they are not part of a standard library, but they're just some of those magic functions that just exist out of the language itself. I guess. Okay. Type object X into object of type Y. Okay. This as function is the preferred way to perform type conversion or typecasting in Zig because it's explicit, and it also performs the casting only if it is unambiguous and safe. To use this function, you just provide a target data type in the first argument and the object that you want to cast as the second argument. And CPN says yes, as in these are the magical built-in functions. So as a fun fact, in NIM documentation, if you look at definitions of some of the functions in standard library that just appear not to have an actual implementation, they have this kind of decorator that says magic. That they magically are implemented by the compiler itself or whatever. It's just funny. Okay. So, because it's explicit, it will perform only unambiguous. Yep. So we provide the target data and whatnot. So we have test. Const X is usize of 500 and const Y is, we take our usize and say it's as U32. Okay. And expect, and again, we have type of Y to be U32. Okay. So and again, another built-in. Alrighty. And Malcolm says the @as is more of a coercion rather than casting. Okay, sure. What do you mean? What's the difference between coercion and casting in that case? Because I'm not sure what you're trying to say. Because casting is always often understood as like as forcible as possible. So coercion is less? Okay, it only works when there is no data loss. Okay, so you're saying that, it's more of a try when it's possible. So yeah, they said it's only gonna work if it's unambiguous and safe. Yep. While with casting, you can just try to fit something inside of the other thing, and that's it. And for some types, it's gonna work. For the others, not. Okay, this is the general way to perform typecasting in Zig. But remember, as works only when casting is unambiguous and safe. There are many situations where these assumptions do not hold. For example, when casting an integer value into a float value, or vice versa, it's not clear to the compiler how to perform this conversion safely. Do I round somewhere? Do I do this and that? It's just so many questions. Therefore, we need to use specialized casting functions, such as in such situations. For example, if you want to cast an integer value into a float value, then you should use float from int. Don't use the word cast here, use convert. That's better, convert. Float from int. Okay, so this is another built-in. Oh, okay. Float from int, why not? Function. So in the inverse scenario, you should use the int from float. Okay. In these functions, you just provide the object that you want to cast as input. Then the target data type of the typecasting operation is determined by the type annotation of the object where you are saving the result. In the example below, we are casting the object x into the value of f32 because the object y, which is where we are saving the result, is annotated as an object of type f32. So yeah, float from integer, and bam, there we go. So in these functions, you provide the object that you want cast in, but then the target data type is determined. I guess because we have float 64 as well, and it will just infer it in some way. Okay. Another built-in function, or in the other direction is like what kind of integer, right? All right. Another built-in function that is very useful with performing typecasting operations is pointer cast. In instance, we use the add as built-in function when we want to explicitly convert or cast a Zig value or object from type X to type Y. However, pointers, we're going to discuss pointers in more depth in chapter 6, are a special type of object in Zig, as in they are treated differently from normal objects. Every time a pointer is involved in some typecasting operation in Zig, the pointer cast function is used. This function works similarly to float from int. You just provide a pointer object that you want to cast as input to this function, and the target data type is once again determined by the type annotation of the object where the results are being sorted. So bytes, which is some random alignment of whatever. Let's ignore that part and say, okay, these are bytes. Okay, then we have constant pointer to constant u32, right? And we want to cast our bytes. So we basically get a pointer to bytes, and we want to cast it to a constant pointer of u32. So it's just a pointer to the first value. And try expect. So we basically have that. All right. Okay, this is a little bit confusing example, but okay. I understand that this basically extracts the first element of the thing, I guess. Wait. Yeah. Because this is type of array of U8s, right? Well, this is a pointer to sorry. Oh, wait. Oh, that's what it is. That's right, because these are 4 elements, so they add up to U32. So we kind of build a pointer to something that is of this size. Okay, and we have kind of forced it to be aligned in one thing, right? Don't spill out. Huh. It's an advanced case. So Spian says there's also in from bool and from enum and whatnot. No, it takes all 4 bytes. Is U32 is U8 times 4. It's casting a pointer to 4-byte array to a 4-byte unassigned integer. Interesting. So I guess this behind the scenes would literally just change the type that it points to without actually touching the data. Therefore, we are able to get our bit array or whatever our byte array that we got from somewhere and just magically convert it to some kind of number. So I guess that's how one could construct, let's say, you get some bytes from the network and you need to construct an integer from them, right? So that would be a technique used, for example, when dealing with if I was to make the Seaboard protocol again. Yeah. So Nokia says it's casting a pointer to a 4-byte array to a 4-byte unassigned integer. Yeah, I mean unsigned integer. Yeah. So yeah, exactly. So in theory, I could grab this, and I mean we won't do the expect because that's not the point. But in theory, I could say, you know what? I'm gonna throw in 0x12 few more times. 1, 2, 3, 4. So that will be a 64-bit, right? So in theory, I could say, hey, this is U32, right? U64. Pointer, we're gonna name it. It'll be U64, and can you do that? A line of U64, I guess. Yeah. So this is, I guess this is so that inside of the memory, it actually is within bounds of a single where the pointer would be starting. Because I guess it could try to get smart and start spilling stuff around or whatnot. Okay, that makes sense. And therefore we can just do fun stuff. Okay. All right. I like that. It's not too bad. NCPN says, I gotta look into line and at a line off. Yep. So this will be definitely for this kind of conversion to ensure that things are lined up properly in memory. I wonder if this in practice might slow down performance or something. I don't know. It's interesting because there's a reason why it doesn't do it by default. And CPN says put a comma at the end of the last element of the array and format it. Oh, as in that will probably automatically, when I save, turn it into a list. Okay, so that's how you do it. All right. I see. So it looks like I have format on save automatically. Okay. All right. This is use64 pointer, right? I run it and there we go. Or I can just do standard debug print. And because it's an integer, we say value is, and this will be use64 PTR. Let's see if it prints it. Printed it, and what the heck? U64, and this is the value, I guess. And for some reason, I guess whenever it's the end of the thing, this gets displayed. Okay, all right. So I could just print it as decimal, and that will skip this whole thingy. No. No. Invalid format string D for type const. Oh, right. There we go. Bam, there we go. Now it's good. And okay, I was already saying it's a pointer to print the value. You need to use the reference. Yep. Makes sense. All right, so it's a big number. Try X. I guess now it won't work, right? Because, hexadecimal? Because we have value hexadecimal 12, 12, 12, 12, 12. And because it's that, we just printed out hexadecimal. Okay, all right. So it actually worked. All right, I can see that. So if I would magically remove one of the values, it will all fall apart, right? Unless in a conversion would just magically spawn a 0 somewhere there. Yeah, it won't work because, hey, exceeds the bounds of containing declaration. Yep. So it won't work. But it showed up only during the dereference when we actually tried to extract the value from the pointer. Interesting. Huh. Okay. But yeah, it makes sense. So I can see this being very helpful in dealing with various streams of bytes. And try removing the align off thing. Yeah, that could be interesting error, right? We save it and probably will work. No. Nuh-uh. Error. Pointer cast increases pointer alignment. Increases pointer alignment. Bam. It's alignment 1. It's alignment 8. Okay, this is alignment 1 of 1 byte, while this one has alignment of 8 bytes. Yep. So I guess this is because our memory is made of 4, 5, 6, 7, 8 individual bytes, right? And you can have them, bunch of them here. And if you want to fit like int64 or something, if you want to fit an int64, you need to have 1, 2, 3, 4, 5, 6, 7, and 8. Wait. 1, 2, 3, 4. 1, 2, 3, 4. You need to have larger boxes, right? So in memory, they will be aligned in this very specific way. But the thing is that when we define that we need an array of U8s, what this could have done is like decide, you know what, I'm gonna define it, maybe I found some room. I'm gonna define it from here to here. Because maybe I had some other data somewhere here, and maybe there was something here, right? It figured out that, oh, I've got some room, I can fit that here. And because of that, if you would want to put it as a pointer, it won't align with like this grid for those pointers. Therefore, by forcing it to align with this, align to actually a 64-bit value, we're forcing it like, you know what, you cannot create it here, you will need to actually align it with this specific grid. So that's how I understand it. That's just how in memory it would work. All right. That's another reason why when you just store 2 Boolean values, you're really storing, you're still using 2 bytes, even though each byte is just using 1 bit of them to make a value, because you can make memory to be smaller. Therefore, your pointers can't just nitpick into sub-values or whatever. Compiler might just compile something away and put things together, but usually you just want to resort to some kind of smart struct that will pack it for you, or you want to resort to bit logic to just put more things. And CPN says, this is getting too low level for me. Yeah, that's the thing, that when you start making the smart things of, hey, I have some bytes, I can construct some larger value out of them, you start hitting those strange situations because compiler tries to be smart in how it manages memory to maximize it and whatnot, and yeah. Nokia, it probably decreases performance since the CPU will need to load unaligned. I guess Bool uses 1 byte, and then Zig Bool uses 1 bit, I think. I think by default, 1 bit, I mean the byte, will still use 8 bytes. Unless you create a struct that has several of those 1 bytes, and Zig will be able to basically compact it and automatically fit it into, generate masks and whatnot. Exactly. Nokia says only in packed structs and in a vector. Okay, so vector also has this kind of fun stuff. Otherwise, a bolt is a U8. Okay, all right. So yeah, that's the thing that as an early junior developer, like, oh, I'm gonna use the smallest values possible. These are all just bit flags, right? Just byte. You make a bunch of stuff with them here and there, and you end up being like scratching your head. Why is this taking up so much memory? I used just booleans everywhere. I wonder, what about even an array of booleans will still even if you're gonna define, hey, give me an array of 8 booleans, each element of array needs to be you need to be able to address to it via a pointer. So therefore you will still need to have, it will still declare an array where each boolean is just one thing. So I guess that's why there exists the concept of a packed array that actually encodes stuff and does some smart calculations. So but I was struct with 8 bools. If you have struct, and I don't know if you need to do something special to make it packed struct, then it would be 1 byte, that struct. But again, the computer will need to do some extra calculations to extract that 1 byte from there. So something tells me that you still need to kind of tell Zig to make it packed or maybe not packed. Because when you think about it, with a struct, right? We had a struct definition here, right? So let's say that I have constant my struct, whatever. I'm gonna do my struct, and I'll be a struct, right? So you could have 2 options here. Packed struct. Okay, so you just have to explicitly say that it's a packed struct. Okay, so let me explain it to you, CPN, why it's actually a deal to be able to specify it's packed or not. So let's say we have this, B1 will be Boolean, right? And we have, 1, 2, 3, 4, 5, 6, 7, and 8 of them, all right? So we have my struct, and bam. So if we have just a normal struct, when we do something like, let's pretend that we have that value somewhere, right? So we have, let's get rid of all this stuff. We don't need all this stuff. All we need right now is our main function so that we have stuff next to each other. So when I'm gonna do, let's say that I have whatever, var, whatever, instance, okay, of my struct. And I can say what it was undefined, right? Okay, so I have that instance. Let's imagine that it's defined somewhere there, but when I'm gonna do instance.b2 is, I don't know, true, right? Let's say that I want to do something of this sort. Now let me just see. Nokium says you can print the size of the struct with the at size of my struct. Okay, we're gonna try that in a second. That's awesome. So let's say that I did this, okay? If I did this on my struct, what it means that basically compiler takes the pointer to the instance and adds whatever offset there needs to be to create a pointer in memory to this specific field where this thing is being held, okay? And what it means that if I am able to have a pointer to this thing, that means that it needs to be on this 8-bit grid. That means that it basically is gonna take a byte because I am able to have a pointer to it. But if we, by any chance, had a second one, my packed struct, and we're gonna do packed, right? There we go. We're gonna do that, and I would say, hey, maybe we have the whatever packed one. Okay. I just won't have. I'll have it undefined. If I'm gonna do packed one.b2 is true, suddenly a lot more needs to happen. So basically, I guess Zig will need to compile it, precompile it, or whatever. It probably replaces this with something where it gets the pointer to the packed one to know where this is in memory. And then it will basically need to figure out in this case, there's just 1 byte. But if you had another thing or mixed some other values in between, it will need to figure out, okay, which byte I need to read to get to that value. So that will be the first step. Second, it needs to extract just 1 bit from there. Therefore, it needs to, do some bitwise logic to apply a mask to extract just that 1 value and then convert it to a Boolean for you, or maybe set it or something like that. So it just takes a few more steps. I mean, these are super fast steps, but it's not just in a simple way of I'm going to calculate the pointer and return you a value. It's going to be a few more steps. And that are, I guess, inlined, I would expect. Inlined or maybe not inlined. I don't know. Don't know how Zig does it, but yeah, just a few more steps. So the trade-off is for less memory, you have slower stuff. Or maybe I'm 100% wrong, but that's the only thing that makes sense. Nokium is probably experienced enough to actually tell us if it's true or not. So let's create this instance and that instance. And do I need to actually create it? Oh dear. My struct. And oh no, I need to do B1 is, wait, is like this? True. B2, I guess I can do colon, right? Hopefully. B2 is false. And then moose struct, my struct. And no, it needs to be this. What the hell? How were we supposed to create them? Where was it? Because I'm getting confused. We have struct. Do we create it somewhere? No. Where's my vector? My precious vector. Dot something is something. Okay. Dot B1 is this. Dot B2 is this. And Nokium says, I don't know if it's slower CPU nowadays, yeah. I would probably need to test it. And CPN says you can give default values for the fields at the declaration. Oh, you can, so you can skip them. That's gonna save some time. Or just hope for the defaults. No error, but whatever. So let's just do this. Is true. This will be a very optimistic one. How about that? So it will be is true. Okay. Therefore, we have this one, and we have my packed struct. There we go. I guess I don't need this declaration. It would be nice if I would be able to do this instead. Maybe it's possible, maybe not. I don't know. Don't care right now. Let's just get it over with. And the hint was size of my struct. So let's do first of all, constant, because it's going to be complaining constantly. So constant size of normal is size of instance. Okay. Oh, of not instance. I didn't actually need to create instances. Dear. Oh dear. It's of type. There we go. At least I'll learn that you can set defaults. Another thing that the book skipped. Size of packed will be my packed struct. And we just do standard debug print normal and debug as bytes. And then we have packed bytes. And this will be size of normal, size of packed. Bam. Let's see if it works. Yes, normal is 8 bytes, packed is 1 bytes. There you go. There's where you need to use the dot something. Ah, okay. Yep. So while we have this set up, what if we're gonna do something fun? So we can do something like U7, right? So fun, whatever. X1 will be U7, right? And that will be value of 0, whatever. Doesn't matter what value. So if I'm gonna do U7, and I'm just gonna throw in that one extra one. So it'll be B0. So therefore, we have a situation where, in theory, in a packed one, this should be 1 byte, because we have 7 plus 1, it's 8. And here should be second byte. Well, this one will be probably 1, 2, 3, 4, 5, 6, 7. Now will be 8, 9, and 10 bytes. So let's see if that's truly the thing. Yep, 10 bytes versus 2 bytes. But does the order matter inside this thing? Because what if I'm going to move this down here? It will be 1, 2, 3, 4, 5, 6. And this won't fit in anymore. So it'll be 7, 8. And this will be a third byte. Does that change, or is Zig smart enough? Zig is smart enough. Okay, so it's gonna rearrange them to kind of try to optimize it. Okay, good to know. So it tries to optimize it. So it's gonna rearrange and do the thinking for us, so we can structure it however we want. Inside of our code, so it's readable and whatnot, and not the other stuff. So yeah, that is awesome. And I don't think I can make any meaningful benchmark here. What if we actually have those two, right? And Nokim says for C interop, you have xterm structs that have the C layout, and it does not rearrange the fields for you. Okay, all right. So that means that in C, the arrangement matters, the manual one. And yeah, you just mark them external, and therefore they have less fun features. Unless manual arrangement you consider fun. So let's try it that way. We are going to basically, I'm thinking, write, read in a crazy loop. So we're gonna make the var as variable, right? And we're gonna say to do start timer. And then we're gonna have for, and we can use our knowledgeable loops. So we're gonna say million, 1 billion, right? Can we do those? I don't remember. I think we can do those, right? There we go. 1 billion iterations. And this will be just I, which we truly don't even care about that. And we're just gonna say, or no, let's use .i. Why not? Let's use .i, and what we're gonna do is basically we're going to say instance. Oh no, because that won't work. So let's skip that. We're just gonna say instance.b1 is true. We just keep changing it. Or maybe we're good at I, it's gonna be I. We can do modulo. I don't remember. I think we saw modulo somewhere. 2. And can I convert that to? This is. I know. I think this will scream at us that this is an integer and not a boolean. Unless it's smart enough that sees that, oh, this is a common pattern with 2, and I'm just gonna allow it, but that would be weird. So that will be this, right? We're just gonna keep changing back and forth the same thing a billion times. It's the stupidest benchmark ever. 2 and timer print time. Okay, and then we're gonna copy it. We're gonna say bam. And we're gonna do the same thing, but it will be not instance, it will be the packed one. And we're gonna avoid this whole U7 and B0. We're just gonna have 1 byte versus 8 bytes. And Occam says, CPN says, you gotta use bool from int. Yep, so we have to. Okay, all right, I can do that. Bool from int. If that exists, no, invalid built-in. Oops. Is 0. There we go. That's an alternative. Okay. So now we need to figure out the timers and whatnot, and I'm just gonna do Claude. And please take a look at 0. Implement the to-dos. We'll see how this can deal with Zig. Because I don't know how to do the timers. Wow, this is really thinking. Okay, so timer is try standard time timer start. And that creates a new timer. So then we do elapsed from this read and we print it. And we just create a new timer. Okay, because the timer can just exist. It's just a reference to some time, right? And that's it. All right. Sure. Let's see what it looks like. Timer is literally U64. I mean, no. Timer. What is the timer? When we do start, it just creates a struct, right? Started. Previous. Instant. Huh. Interesting. Instant now. Okay, so I guess that's just a different type of time. This is a timestamp, and if it's POSIX, then this other. Okay, so this is purely so that it calculates stuff depending on the platforms correctly. Okay, all right. Let's see if it runs. Oh, it's doing something. So it compiled. I hope it doesn't do the calculation during compile time, right? We have vars and whatnot, so it shouldn't. Size of no. Oh, it's just gonna print the size afterwards. Whatever. So no. Whoa, that's nanoseconds. Okay. We'll see if there's any significant difference. I mean, I'm streaming right now, moving my camera. I'm talking. Talking is more filters to calculate. So I don't know if there's any actual difference between the times. I don't know. Whoa, okay. I mean, that is a significant difference. This is over twice as long when it comes to time. Wow, okay. So might be slowdown, all right? I mean, you're probably not doing billions of operations, but maybe if you have something that really needs performance, you basically are not going to use packed once. But if you need to do something where, okay, I'm going to have billions of this instances or whatever, and you need to save on memory, you're going to be like, you know what, I'm going to throw it in a packed one because I read it maybe only 1,000 times a second in a game or something. So yeah, there you go. We learned something that's way beyond that book, I believe. All right. So we went here, we went to typecasting, and we're nearly finished. All right. I mean, I don't have like a newest processor, but it's not an old one. It's whatever, 12th generation Intel i9. So, a decent processor. I mean, this is one threaded, but still, it just needs to do extra work. I guess it will be fun to see it in. Zig to assembler online. Do we have a website like that? There's a compiler explorer, right? Okay. That might be it. So we want to get Zig. There we go. There's Zig. Export function, this and that. So let's do this. Right. And I'm trying to figure out how to make it as simple as possible. So our function will be basically set one of those, right? So we're gonna create a new instance. So it's gonna be create a new instance of this thing. And then we're gonna do instance of B1 is false. And that's it. Void. We don't take anything. And that's it. All right, so we've got some assembly code, which, by the way, I totally don't understand. But we have a square, which is our function. And then we have this, which says 1 byte explicitly. 1 byte, 1 byte, 1 byte, 1 byte. Oh, that is so funny. So I guess it's just an array of bytes after all, right? So we have push, something here, move this, move that. So can I actually make it where I have, let's call it normal. And then we're gonna have hacked. My hacked struct. Oh, nope. And we just need to get our packed struct here on the list, and we're gonna be able to see how much difference there is with single assignment. Compiling, compilation failed. Great. Whatever, smaller. Yep, packed as occurred. Yep. All right. So when looking at the stuff, we have unnamed one, which is a bunch of 1 bytes, and The other one doesn't even exist. Okay, sure. So normal, we have just this. For smaller, we have all this extra stuff. So the first one is push this, move that, push that. So the two first ones are the same. Next one, with a smaller one, don't know what's happening here, but we're doing this. But here, basically move keyboard pointer to this pointer -8. So it's doing something with bytes, and I guess assigning value of 0 to be false. Gonna do it true, it will change it to 1. Yep, it just changed it to 1. There we go. So when I click on stuff, it doesn't, I mean, it shows by line, right? So this one, instance creation, whoa, okay. Oh, so with instance creation, as we can see in line 16, the packed one is literally just create a pointer to a byte and call it a day. With instance here, we, I guess, create a keyword, which will be, I guess, a value length of 8 bytes. And in both cases, I guess Zig is pre-computing it, right? Because for this one, a computer, you know what? This is just value of 1, I guess. What if I'm gonna make the default to be false here? Look at that, -3 something. So the assignment's still one thing, but it just does some magic with bit masks that, okay, I did that, this is value of 3 or whatever, we just subtracted it. Okay, so this is Zig compiler doing pre-compilation for us to just pre-compile that, okay, if this is default thing, it's just one number, right? It doesn't need to do anything. Well, if we did the same thing here to false and here, it's gonna be probably very similar. Oh no, it precompiled it here. So this is our, oh, so the default value was created as basically in memory existing thing at all times, right? And therefore here we basically, you know what, load it here and copy it here. And that's it. So that's the difference. Okay, truly fascinating. But when we set the value true, the instance true, whoa, this really highlights stuff, doesn't it? It's gonna be just whatever, the byte pointer. So what we're doing here, I guess we're basically calculating which pointer to a byte to get. And at some point we add something to it, whatever. Somehow we make it true. If I would make it false, what is it going to be? Instead of 8, is going to be something else? Oh no, in a first line already. So false, true. Okay, so that's just the first value. Byte pointer, whatever it is, -8. Okay, I guess to find which byte it is, set value to 1. And then we have RSP1, RBP pop. So this is basically exiting the stack, okay? So that's that. If I would say then to maybe do B2 to false, right? And we're gonna do the same thing here. We see that here it's just one operation to set the value. And it just literally calculates the offset of the byte, right? While here, to set the first value, we need to do all this fun stuff. Oh, wow. And we get a pointer, we do, who the hell knows what that means? And the same thing here. So a little bit more things for the processor, a little bit more cycles to cycle through to actually get to that. Holy moly, I did not expect that it's going to be that big difference. One move. Whatever that means. I wonder what this move AL. I wonder if it's moving literally some kind of, no, because we have and shift left. XOR and shift left or. And so all those are to pre-calculate the final byte value in this AL register, and then we just apply it here. And Nakim says, try passing O release fast. Yeah, AL is registered, CL is registered. These might be some kind of arithmetic registers specific for bit logic. And here we have like those generic one like EAX or whatever, and whatever those are. Some people know what it means. Compiler options. Wait. Dash O release fast. Oh, whoa. What the hell? It compiled everything away because I think it just figured out, you know what? Nothing is happening here. No space. Okay. Slow? Oh no, wait, it's safe. Yeah, it just tried in your code. On my code. Oh, that's what you mean, to actually run it and see if it does different, right? Release fast. Whoa, that was faster. No, the packed one was faster. Oh, this is funny. You know what? It just figured out that calculating this, there's no point. After running it that many times, I already know what the end value will be, and it just runs it. That's all it is. So it's cheating. Because there's no way it's gonna run over those iterations. I'm gonna do this. And we're gonna make it. I don't even know how to make it into not U size. This needs to be U64. Can't. Constant iterations will be U64. This number. Bam. Nakim says use the standard time nano timestamp. I'll tell that to the thing, because I guess I would need to get nano timestamp. I guess yeah, we'll do that. So standard time dot nano timestamp. It's I128. There you go. And we're just gonna do elapsed is timer 1. I mean, we do this minus timer 1. I'll keep the names the way they are. Of course, never muted. Constant. And we have this. Oops. And laps 2 will be this minus timer 2. And that will be more fun numbers. In the meantime, iterations is this thing. And we're just gonna say from here to here. And it just says it's gonna be U size. Really? Oh, because it's probably already on my system 64-bit, right? Expected error union type found. Oh, no try. Yep. And SPN no try, I think. I meant as some value for the addition inside the loop so that it can't. Oh, that's what you mean. Okay, all right. I mean, here the time didn't increase much, right? It's just still it is a little bit larger, but I don't think necessarily specific. So we could do, instead of I, right? We're just gonna ignore the I and we're just gonna make it back to maybe 1,000,000 for now so that we have some manageable numbers. Instead of I, we're gonna do the thing, which is standard time nano timestamps, right? We're gonna try to divide that by 2 and whatever, have this calculated. It's gonna slow it down like crazy, but maybe it's not gonna be that bad. Signed integers and floats must use loads. Signed, because these are signed. Really? Okay. So that was the add rem or add mod. Okay, I guess something like this would be good enough. And we can do exactly the same thing here. And because of that, we don't need the outer thingy to make it a little bit cleaner. And there we go. And run. And now it run. And now the pack struct is faster. At least during compilations. But hey, at least we got some numbers, right? So let's just increase the iterations, but 1,000-fold to 1,000,000,000. Bam. And we see how that goes because it's going to be 1,000 times slower. So probably a little bit worse, but that's a good idea with the time. Yep. That's a very good idea. I'm not used to do this kind of benchmark stuff. So this is fun. Come on. Normal struct took whatever the number is. And this one was pretty much the same or just tiny bit slower. How interesting. So during debug was really bad. Here it's really, really, really nice. Save. Let's just, because the discrepancy is so small, I'm just going to decrease it. Maybe make it 10 times faster, okay? Let's see what's going to happen. So really save. Come on, you can do it. And let's see the same time. All right, so this is very, 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 very unexpected. Thank you for pointing that out. Always try in release mode rather than in debug mode, because we're gonna get back to debug mode and it's gonna be like, nope, it's gonna be vastly different. First of all, larger. Second, just weird. And CPN says, try again using the timer, please. What do you mean by running a timer inside of this thing here? Wow, this is, I mean, wow. How many times slower? Around 16 times slower. Yep. But again, discrepancy isn't that large suddenly, because I guess, yeah, I guess this getting the nano timestamp is bad. What do you mean by use timer, please? Because I'm not sure what you're talking about. Whatever I'm doing here with this nano timestamp, whatever, is pretty much the same thing as the timer would do. The timer I had earlier, yeah, that would be pretty much the same. The timer, I would need to do standard time. Timer? Or was it like new timer or something? I don't even know what that thing was. Do I have this thing somewhere? Timer start. Yeah, it's pretty much the same thing. The timer is just like a convenient method to just have the get elapsed, whatever, because you can call it multiple times on the same object. And that's pretty much it. Okay. All right. Yeah. Wow, that was so much faster. And timer start, yeah, that just sets the timestamp on it. That's all it does. And I think creating it probably just does it, yeah. Yep. It's just a little wrapper around basic function. Okay, so this showed us that it does the same thing. And here we were able to, oh, because it pre-computed here, yeah. Gosh, I'm really curious about doing something like this. Iterations. Bam. I really want to see what it looks like as difference from in the like assembly or whatever. So can I do this for iterations? Do this fun stuff. And we just need to get the standard thing imported. Hopefully that's not gonna show up in assembly. And I guess we can actually, in a loop to not confuse ourselves, let's do constant time is, or just whatever value is this thing. And B1 will be value. That will be our iterations. And the same exact thing is happening here. Yep, the only thing is which one we created. And compilation failed because of reasons, right? Says error somewhere here. Line somewhere here. Oh, of course. We need our semicolons. There we go. They were hiding on a zoomed in screen. So in debug mode, come on, you can do it. You can do it. And Alchem says, I think the compiler is being smart here. Both are writing to the not packed struct. Huh. Maybe. We will need a real world example. Because in this case, the normal looks like this, while the packed, where's packed? I mean, small, right? Gosh, I guess we have an entire library here. Where's smaller? We don't get a highlight. Reveal linked code. There we go. Smaller is very much the same. Goes here, and for when we assign this, yeah, it basically does the same calculations. So what if we do, what was it? Release fast. Now as the watch list code, it just removed a bunch. Normal, our thing here is nowhere to be found. Reveal linked code. Doesn't show anything. Reveal linked code. Doesn't show anything. Of course. Yep. I don't know enough about it to actually make it work, so that was fun. That was fun, but it will be interesting to find, like, make actual example that maybe does something more smart that confuses the hell out of compiler, so it doesn't do it the way it's supposed to. But at the same time, it will just make it more difficult to actually measure the performance difference. Because again, most of the time, the vast amount of wait time is not just the save and read, just everything around it. So it's like, reading checking the little small thing that doesn't really matter. All right, so we went to typecasting with the as and float and whatever, and we had the fun stuff, pointer cast with the alignment. Okay, that got us on a crazy rant. So let's finish off with the shortest chapter, modules. So we already talked about what modules are and also how to import other modules into your current module. via import statements. Every Zig module as in a .zig file. Okay, so every .zig file is a module, right? That you write in your project is internally stored as a struct object. There we go. Take the line exposed below as an example. In this line, we are importing the Zig standard library into our current module. Constant standard is import bound. When we want to access the functions and objects from the standard library, we are basically accessing the data members of the struct stored in the standard object. That is why we use the same syntax that we used in normal structs with the dot operator to access the data members and methods of the struct. When this import statement gets executed, the result of this expression is a struct object that contains the Zig standard library modules, global variables, functions, etc. And this struct object gets saved or stored inside the constant object named standard. Take the thread pool Zig module from the project Zap as an example. This module is written as if it was a big struct. That is why we have the top level and public init method written in this module. The idea is that all top level functions written in this module are methods from the struct, and all top level objects and struct declarations are data members of the struct. The module is the struct itself. So you would import and use this module by doing something like this. The standard import standard, then we have constant thread pool is import, right? So imported it. Constant number of CPUs is standard thread, whatever. If we had an error here, just panic. And constant number thread, standard math cast, U16 number CPUs, whatever catch standard math max integer. And there we go. Pool is max thread pool init. Thread pool init, and we do that. So we just call the function init on it. All right. And that will basically create the thread pool that will have all the other methods available from pool via dot. Okay, makes sense. All right. Great. So that means that we can probably import by just dot notation or whatever. So that's cool. So in theory, I would be able to grab those two structs, or like something like, yeah, let's say I grab those two structs, right? We don't need math anymore. We're going to do constant. My structs is import, and this will be maybe dot slash my structs .zig. Okay, gonna do that. For now, it doesn't work, but we're gonna save it. We're gonna go a little bit higher up. So let's just go neovim, and this will be, what do I call it? My struct zig. My structs.zig. Okay. Go away. Let's paste this in. And I guess we need to make it public, right? Because, oops. Undo. I can't still. I can't talk and use neovim at the same time. It's a little bit more difficult than normal editor. Okay. So I guess this will be enough. We just need to do my struct dot this thing. Okay. Or we could probably do that const my struct is, there we go. Okay, so we can do something of this sort, no problem. packed. Whoa, what the hell? Where'd that come from? All right, and it just works. All right, that's cool. So I like that this is simple, just like in JavaScript, you can move around. It's not some weird stuff like in Dart that drives me nuts that you can just split stuff easily. So this is fun. And Nokium says, I'm going to sleep. Thanks for the stream. Thank you for helping out. It's really, really, really helpful. And Nokium also said, both while writing to the notebook stream, you can use the volatile keyword to not optimize it away. Yeah, it's more. Yeah, let's move on. Since it's always writing to the same bit, it probably can pre-compute the mask or something similar to that Red Bull earlier. Yep. And I'm going to sleep. Thanks for the stream. Awesome. So yeah, we basically finished this thing, right? We finished the chapter. So next time, I don't think it's going to be this weekend. I have some prep to do for the interviews. So probably somewhere in the middle of the next week, we're gonna go through memory and allocators, and that's gonna be another long one. But I think this is where we will start finally learning what Zig can give us as software engineers, where the safety comes from, and start having fun with heap and actually doing something with more data. So this is gonna be fun. Yep. And we'll see how it all plays out, because so far the design is very interesting. I am genuinely intrigued by the language. It's kind of fun, yeah. SCPN says, try removing the first and 10th line of the MyStructs Zig. Wait, which line? First and the 10th. Oh, as in, I mean, that would be where I would be able to, yeah, if I will basically do this, right? I can then do, then in theory, I could do, my struct is this. Okay. And this will be my struct.myPack struct, and there we go. Yep, makes sense. Absolutely. This way you can make structs in a funky way, but I'm still confused by the fact that you can have it like a constant, and can I do var? Will it compile of that? Right, all. Error, import a file outside the module path. Oh, wow, okay, we have some extra problems here because it's trying to go back. Okay, so maybe it's not that easy, but yeah, eventually we'll get there. But that will be it for tonight. Thank you for watching. Thank you for hanging out with me, CPN. And good luck on the interview. Thank you. We'll see how it goes. It's gonna be scary. All right. So thank you again, and see you next time.